This piece of content is brought to you by JLC PCB. You can get their transparent Flex PCBs for only $5.80 with the coupon below, and that is a $10 off coupon. And you can also, by the way, get 25% off Microsoft software at CDkeyoffer.com if you use offer code Broken Silicon. And we'll talk about these sponsors more later, but for now, let's just get on with the show. And welcome to Broken Silicon, a gaming hardware podcast. I am your host, Tom, and today I am joined by someone that I feel like everyone watching this should have eventually seen one of the episodes you've been on, but if somehow some of the people watching have, which I suppose there's always someone, please introduce yourself, tell people what you do, and I think an interesting additional question might be like, what's the main driving force that makes you keep doing what you do on YouTube?
Hello, I'm Wendell from Level 1. I'm basically an internet rando, computer janitor. I like solving puzzles, and sometimes that translates into doing a video on this thing that I figured out, or something I discovered, or just waxing poetic about some random Linux thing, or whatever. Or, you know, whatever's going on with technology in the news, and how that relates to things, and discovering stuff. I don't know. Playing games, that's also always a lot of fun. Although there's the metagame of like figuring out why certain things perform the way that they do in some games, but not other games, and then also poor game optimization. And then like some games can crash, like Minecraft can degrade silicon. That was fun to figure out. So yeah, I don't know. I'm Wendell from Level 1.
Well, that's always something that I've realized, if I get a game on console, it's going to boot up. I'm going to start playing. If I get it on PC, there's going to be at least once a week, especially the first week I get the game, where I'm just maybe for an hour or two messing with the settings and going, well, that's interesting. That setting drops the frame rate this much. I wonder why that is. And then that turns into its own game on its own.
It's a mini game. It's a fun mini game. It's like the old DOS mini games where it's like, okay, how am I going to have to, load my drivers in a certain order? It's like, load high equals something. I can barely remember. That was when I was like 8, so, it's been a while.
Well, I'm curious, too, when you said you like solving problems, because I recently had on High Yield, who is a YouTube channel, and I asked him this question of like, was there ever a point you were worried you'd lose interest in making YouTube videos? Maybe not last year, but 5-10 years ago or something.
I mean, sure. Yeah, there's a lot of, I've been very fortunate in that the audience has been kind enough to me to allow me to hire people to do the things that I don't want to do. Otherwise, I would probably do a lot less of it. Mm-hmm. And so it's more just like, I figured out this thing, I have to share it. And then so some people enable me to do that. And that works really well. Although there's probably more of that. Like I could probably get into more of a mode of like, this is a thing that I figured out. I have to do that. But as we're entering this crazy era of like AI and hardware and even more acceleration. And so there's been kind of this acceleration in the industry. And so I haven't really had to run up against anything like that. It's also been really interesting watching computer science, like what computer science means expand, but also how basically every job, it's like you're a computer scientist and something else. And that is, sort of people's career trajectories as well. I found that very, very interesting over the last 5 or 6 years, and that making content to help people understand how, at least understand things how I understand it. People have told me that has helped them in their career, even when it's technology adjacent career.
Mm-hmm. Yeah, I've seen some comments like that myself as well, and what you said though I thought was interesting because it's like I never really was worried, but I would say maybe 3 or 4 years ago, I was like, this is a lot of work, maybe. And then when I first started the YouTube channel, I would like bank videos because I was worried I wouldn't have something to talk about in a couple weeks. And over time, I realized I'll always have something to talk about, actually. That's why I started this. And you saying that you're always trying to solve things, it's like, I think I have to imagine that eventually you were just like, it's always going to pull me back in, like that worry that you might not be interested how many years have to go by before you're like, I'm always going to be interested? That seems pretty obvious.
It is 100% Lucy with the football with me and the year of the Linux desktop.
Oh, I see. Like, when is that going to happen?
Here I go, kicking that football. Oh, yeah, the Linux. And with Proton and SteamOS coming to multiple devices, and also, like, the Strix Halo. Like, I have a Strix Halo device here. This is the ROG Flow. Like, the Linux experience on a 128 gig Strix Halo platform, whether it's this or the HP G1A, like, it has been a long time since I've been once again yet this excited for the year of the Linux desktop football. And this is a better gaming experience on Linux than it is on Windows by a country mile. Even like Helldivers 2, like I don't know what is going on with the Helldivers 2 anti-cheat on Windows, but it is a mess, and probably somebody's going to get fired. But on Linux, it's a dream because there's not all of that garbage.
Well, so wait, let's actually pivot to that now, because I had some questions about Linux and different operating systems. Join Patreon, XTX999, shamelessly shilling, I guess, for us, writes in and says, Valve looks to be going all out with SteamOS and handing it out to other handhelds. All I do is game on my PC, so the moment they make a desktop version capable of having Discord and browser functionalities like YouTube, I'll definitely, at a minimum, have a separate boot drive, I think, with it installed and only use Windows for games not capable of running Linux. Do you think these initiatives Valve is doing with SteamOS, will light a fire under Microsoft? They don't even have to do much, but the minimum, which is to make sure that Windows is working enjoyable and a good experience, but that seems to be hard for Microsoft.
I have no evidence that Microsoft actually cares about this anymore. It seems like Microsoft's on a trajectory of enabling Windows as kind of a cloud OS, where like you sign into the browser and you basically get a remote desktop session to something somewhere in the cloud.
And OneDrive destroys all your files for you.
Yeah, well, I mean, just basic using your brain stuff. It's like, okay, OneDrive. And it's like, okay, I've got a corporation that I work for, and then I got this other corporation that I moonlight for, and then also my own personal stuff. And it's like, how does OneDrive handle this scenario? Very basic scenario. It doesn't at all. And there's so many things like that in Windows. It's like, let me ham-fistedly shove down your throat this thing that I think that you want. And it's like, no, Windows, please don't do that. And it does anyway. Meanwhile, again, Linux. So like that person could probably try like Bazite as a distribution right now and probably have a pretty good time. I did a how-to on the forum for Strix Halo with Arch. And the reason for that is because you can very easily run bleeding edge kernel, Linux firmware, solve some MediaTek driver problems that don't really exist as bad at the bleeding edge. And then that plus, because that's kind of also, I think, what the people working on Proton and Valve's SteamOS, I think that's sort of where they're developing and then pulling things out and putting it in SteamOS. I think it's common knowledge that SteamOS has Arch as a common ancestor. And so the experience there is very good if you follow the guide, and you got to learn some stuff about Arch and that kind of thing. But once you get it up and running, it's surprising how little you have to know about package management and updates, and it is very near to a first class experience. But again, Lucy football situation with me, maybe.
Yeah. I want to touch on something you said. I haven't thought about this, but I think it's apparent this seems to be a thing Microsoft is trying to do. Like, an issue I've always had with Android and iOS, although I have used Android 99 times more than I've used iOS. They seem to have built this operating system that admittedly seems to work good for a phone. You don't quickly check your files. They're just somewhere. You can, open up the drive and look at where the files are on Android. But the operating system is fundamentally built for you to not worry about that. They put apps on your main screen. You can organize it. A lot of my parents don't. There's just 5 pages of apps, but that's how it's built to be. You scroll with your thumb, you find the app, don't worry about where the files are stored, don't worry about how anything under the hood works. It's supposed to just kind of work for you and be quick to do because, well, it's meant for a phone. And on Windows, it's very much so. No, I like putting my folders that are on my desktop to a few as possible, and they're in the corner of the screen, and I organize my pictures here, my videos here. I have a drive for these games here, and I like to know where my files are and organize accordingly. And Microsoft seems to be moving more and more and more and more towards kind of giving you a more Android experience. Would you like, from the perspective of, don't worry about where anything is, we're just going to manage it all for you through the cloud, right?
Yes, that seems like an apt description. I would go a step farther and say that it is. We really would like to train AI on literally everything that you output. So we really just, don't worry about where everything is, because we need that to go into our training model.
Right. And like fundamentally, that's probably why they're willing to take a worse user experience to gamble for the hope that they'll have the best AI stuff in the future.
Yeah. You can just sit down and talk to Copilot and be like, Copilot, I'm feeling really sad about the work that I did yesterday. And it's like, yes, I remember everything that you did yesterday. And here is why you should feel sad. And I don't really want that as a computing experience. That's actually kind of horrifying.
So you said it's Lucy pulling the football, this Linuxification, shall we say, of like desktops and laptops going mainstream. Do you think there's a real chance this is going to start happening, though? I mean, might it be niche where it's like 20%, like people like me and you eventually? Really, it is just Linux because Windows doesn't do what we want it to do anymore. Do you think it could be more than that, though, where there's like a bifurcation where like actually a lot of people, maybe older people, use Linux, but younger people don't? I'm curious how you could see that developing, or if you, because like even if it like every gamer used SteamOS eventually instead of Windows, that'd be quite a coup for market share.
Yeah, I mean, yeah, there is an aspect of it that is horses for courses, sure. There's an aspect of it that, in terms of like app innovation and like what is the developer experience like, that it seems like Microsoft has already basically taken steps to abandon Windows. Mm-hmm. If you look at CUDA and the development experience on Windows natively for machine learning stuff, Windows is starting to look like the platform is abandoned from a development standpoint. There's the Windows subsystem for Linux, which re-enables, like, if you want a less terrible experience with Python, Windows subsystem for Linux. If you want a less terrible experience with CUDA, especially CUDA 12.9, the Windows subsystem for Linux will give you a less terrible experience developing on Windows than on Windows natively. I mean, we just, in the last few years, have gotten a reasonable terminal program and a reasonable command line interface. Microsoft was all in on the registry forever. And then they're like, oh, we probably should do some of these things with PowerShell. And now, like, managing a system and managing system state and configuration is much more reasonable through PowerShell. And it's like, there's a lot of, like, I would call it Unix philosophy that's leaking into Windows. And as a result of that, it has made Windows more stable. But if you look at it, if you take the derivative of that and you look at how much these things are changing, Linux is still changing faster than either Windows or Mac OS. And so eventually, at some point, those lines have to cross. That's just the math of the situation. Unless the derivative changes, acceleration happens on one of those two platforms. But I think that your instinct that this is a mobileification is kind of right. Is that most of the focus of Apple and Microsoft is in more of a mobile experience, or more of a device agnostic experience, let's say.
Do you, and there's no way for us to know. I mean, it's all going to be anecdotal evidence and just by common sense, right? The people we talk to are probably more technically savvy, and the people they talk to, even if we don't know them, are probably more technically savvy. We're in the bubbles and the like those diagrams of circles of people who know each other overlapping, where it's probably a more technical bunch, the bubbles touching us. But do you think anyone wants that out of Windows? Because I don't know if no one my age seems to say they want it, but those are my friends.
I show people sometimes the experience that I have with computers, and they're like, oh, I want that. And it is different than what we have right now for a desktop experience, and is a little different than what we have as a Linux experience as well, in that on my phone I can access Nextcloud, and I can access my media server, and I can access everything, and it's basically my own little private network built with Tailscale. And it is less concerned with like a specific machine as much as it is like, I'm working on Project X. I can hit a button and bring my Project X experience to whatever device I happen to be at. I have that with my books and video game. Well, it's like older. I have like retro video games, and so like it's like, oh, I want to. It's not enough to be able to access my old retro video games. I also want to be able to access my old save games. It's like I'm on a plane and I'm kind of bored and I'm on slow Wi-Fi, but I kind of want to experience. It's like I want to load Indiana Jones and the Fate of Atlantis, and then load my specific save game that I'm thinking of, and just like play through the dialogue and click on some stuff and see how that goes. And it's more than just having access, to a copy of the game. It's like synchronization for all of that stuff and how all of that works. And it's pretty easy to build that with open source tools, but it's not a turnkey like operating system experience. Microsoft certainly demoed that with Copilot and OneDrive. They did when Apple was doing some amazing things with the iPad. Microsoft did this completely faked demo of like their Courier tablet, and it's like, oh yeah, here's the Courier tablet. Here's how we're going to do all this stuff. And there's a lot of forward thinking in how they architected the user interface and what people want to do. And then by the time it got around to implementing it, it was the thing that they implemented in no way resembled the thing that was in the Courier demo video. But people still want the experience that's in the Courier demo video. And again, for whatever Windows is evolving into, we don't have that. Apple, for their part, they seem to be building the Courier tablet experience themselves at this point, where iPad, phone, laptop, it all just sort of bleeds together. And I could just move a running app from one to the other. I think that's the experience people want.
I'm curious, do you think that seems to have gone nowhere so far? Because at the end of the day, the teams that are getting the most attaboys from management and like, hey, I'm curious how that's going, is the people that are finding ways to feed the data into the LLM so they can just work on AI stuff. And that's it. Like, and because I think a lot of with Nvidia is, even though they're technically spending the same amount on GeForce, I just don't think the people working on GeForce are getting recognition, and there's no focus on it. And so their drivers are suffering. And I think that's just, if there was a fire lit under that team, maybe the Courier thing would have happened, but it never actually was something they wanted to do, really.
Yeah, I think a lot of the focus in Microsoft has become kind of a myopic, like a line on dashboard must go up. And an example of that is like the start menu. I did a video on how awful and useless the start menu was years ago. And Microsoft has actually tried to make it somewhat less unusable, but it's still that when you click on the start menu, like I experienced a great example this morning. I'm still jet lagged from Computex, and I wanted to play Clar Obscur, which is installed on my machine. And so I hit the start menu and I just typed it in instead of trying to find it. And the shortcut to the Windows Store came up immediately before the shortcut that's on my desktop. And it's like, and I hit enter, and it took me to the store, and it's like, you can play this on Game Pass, or you can buy it for $49. And it's like, this operating system is so moronic that it's so stupid. It doesn't know. And it's like, we've got Copilot, we've got intelligence. And it's like, all right, let's put intelligence here first, please.
But that's the funny thing too, is like the smartphoneification of Windows. If I were to do that on my phone, it would pull up the app I've downloaded before it would try to sell me another one. So they're even making it worse than Android works.
Well, the first thing is that a line on a dashboard somewhere went up, and somebody's like, oh, we got some really good Bing and Windows Store engagement from this awful, awful, awful design.
Yeah. Well, let me ask you this. Colt Marshmallow writes in and says, good evening. It's the afternoon here, but with the Steam app coming to Xbox, is that a win for Valve or Microsoft? Does this have any impact on SteamOS coming to desktop? Now, I was actually Googling it. Well, we were just talking to make sure I understand the situation. I think there's been a rumor for a while that Microsoft might bring Steam to Xbox, but recently, apparently, Microsoft shared an Xbox like store page, like opening billions of doors with Xbox, and one of the screens they showed an Xbox with a TV or something with Steam in the corner of someone launching it. So clearly it's kind of like, what was it like? Was it the GeForce Now leak where we learned God of War Ragnarok was coming? It's like somehow and we've had Netflix leaks as well, where for some reason Netflix knows a new Sony game's coming out, and that's just in their files, and they try to delete it quickly when people notice. But anyways, it seems like there's some evidence this will happen. If Steam did come to Xbox consoles, I'm kind of wondering what you think about that and who that's a bigger win for, Microsoft or Valve.
I think it's a bigger win for Valve than Microsoft. I think one of the reasons that it might we might be seeing this kind of thing is so the Apple thing. Bear with me for a second. And the Epic Games thing. Microsoft is probably looking at what's going on with the Apple App Store, and people other than us are starting to realize that these are just computation devices. There is an antitrust aspect in preventing people from being able to run arbitrary applications on a device that they own. Right to repair, just applications. I mean, the IBM. Think about how much more depressed economically the entire planet would be if IBM had locked down the IBM
Yeah.
PC to only be able to run IBM applications. It's a foregone conclusion that it is probably one of. I'm almost certain that it will go down in history as one of the most moronic things that society has ever done to allow a walled app garden to exist as long as it has, with no option to be able to sideload or run any other arbitrary applications. And so Microsoft's probably looking at what's going on in the Apple situation, and they're saying, crap, we're going to have to allow other applications. Because there have been situations in the past where you could run a remote desktop application on Xbox. And then remote desktop is good enough to do 30 FPS 1080p streaming, or at least the protocol is. And then all of a sudden it's like, hey, some weird randos figured out how you could do 1080p 30 FPS streaming over the remote desktop app from an Xbox. Oh, we got to shut that down. And it's like, well, that's kind of an antitrust situation now, because it's like you literally, somebody figured it out, and the whole reason you're shutting it down, there's memos and emails that exist to this effect, which the emails from the antitrust thing from Epic and Apple is just incredible. But so you have this situation now with Microsoft, and they're looking around and they're like, okay, we're going to have to let people run arbitrary things.
And so you think that's them forward looking and thinking to themselves, eventually they're going to make us do this anyways?
Probably. There's probably an aspect to that. And I think that being able to stream your desktop from somewhere, it's an inevitability. And so being able to do that from a gaming perspective as well would also be good.
How much so do you think? Because when I see this, I'm sure you remember Origin, which became the EA app, and then Uplay, which is still around as Ubisoft Plus or Ubisoft Connect, I think. And there still are way too many launchers, but there's tons of launchers. There were even more in the past. And then they tried this thing where they were like, I think, what was it? Battlefield 4? I think you needed Origin. And once that happened, they were like, well, everyone's going to get Origin for that. And then once they do that, they're going to buy other games on the Origin app instead of Steam. But that never happened. And they still let you buy their games and use their own launcher, usually, I think. But I just think there's a degree of this where I feel like a lot of studios realized we were losing sales on PC by forcing people to use our stupid launcher. I mean, how much of this do you think could be a degree where Microsoft just realized that? Because, I mean, it seems apocalyptic, the fall in Xbox users over time here. And like this might just be them doing anything they can to keep people on their Xboxes, where they might still buy other things and do other things. Do you think there's any of that?
Yeah, I think that the long play here has to be to try to turn the Xbox marketplace experience into the Windows Store. Because like Game Pass is probably the most successful thing Microsoft has ever done toward a Windows Store. And Game Pass is the least bad value thing that Microsoft has. Or maybe I might even go so far as to say is not a bad value. And something like that for the Windows Store, or like a Windows commerce experience, could be good for Microsoft. Letting other app stores like Steam exist also could be good. There was also there were rumors, I don't know if this is true or not, about like Microsoft and like when Gabe steps down, like is there a merger? Is there an option for that? Like Valve is kind of a standout in that they haven't really behaved super sociopathically. I mean, they have DRM, they have protection. There's a lot of things that I don't like about how Steam handles, my assets. But they have been far less sociopathic than
mostly benevolent, right? Like letting you play offline, even though they could stop it if they wanted to.
Yeah, and game developers sometimes don't have They're not doing crazy things. And Valve has also been really a good guy behind the scenes, wielding an 800-pound, like an 800-pound gorilla wielding its might, with the whole anti-cheat thing to try to build good Steam experiences. And they're getting ready to add new labels to the store to make it upfront to be like, hey, this game has absolutely sociopathic insanity DRM. Maybe you want to think twice before you buy this game, because if you plan to run it on Linux or a Steam Deck, the company that's selling you this game could totally rug pull you. And I think that's great. I think that's a great way for Valve to handle that, uh, in a way that would encourage better behavior in the market. It's wild to me how, like, idealistically capitalistic almost the Steam environment is compared to the developer experience, and like, is capitalism good in terms of a walled garden app experience from literally any other platform? And it's like, we're trying to create a situation where gamers can vote with their wallet for things that are in their own best interest, while still giving some controls, and recognizing that you can't 100% trust the user, but you have to give the user some trust. Contrast to, say, Sony, where Sony believes that rootkitting and bricking your CPU is okay, or Nintendo's now adopted that stance as well. It's like, oh yeah, it's okay to brick your console, and it's like, all right, let's vote with their wallet then.
Yeah, and the Nintendo thing, I mean, the things I've been told by developers making games for the Switch, and the amount of control they exert over, like, even like how much storage, and there's like still, even on the Switch 2, going to be a limit to how many writes you can do, like a certain amount of time, because of how cheap they make their storage devices, and like charging extra for others for like actually modern game size, like 64 gigabyte storage cartridges that do not cost that much to make. But then they're so much more expensive that developers choose to buy the 16 gigabyte one and make you download the game anyways. Like, it's quite a polar opposite, I would say. It's quite insane to me. Are you too depressed to go outside because of how expensive Microsoft software is? Well, there's absolutely no need for that. Just go to CDkeyoffer.com. That's right, this piece of content is once again sponsored by CDkeyoffer.com. And I say once again because they've been a fantastic sponsor of Moore's Law is Dead and its community for many years. And that's because they always deliver the best pricing reliably for Microsoft products like Windows operating systems, Office software, and they also sell games and other things as well. So make sure you check them out, especially during their Easter sale going on right now. And if you do, use offer code BrokenSilicon to save 25% on all Microsoft software, and then Die Shrink to save 3% off on everything else on the website. The community uses them. I use them for my new Zen 4 X3D desktop. And Jesse here needs to stop moping around, and I think use them as well. So that's, once again, support Moore's Law is Dead by going to CDkeyoffer.com through the links below today. It's okay, Jesse. It's okay. But let me ask you this, pivot a little bit here. Cure Boom writes in and says, "Hi, Wendell and Tom." To Wendell, when you and Steve over at Gamers Nexus made the bold statement about the x86 architecture being on a doomed trajectory compared to ARM, how certain is that outcome? Were you just kind of saying that, or have you heard any whispers on the replacement for like an x86S initiative? Alternatively, if x86S doesn't happen, is the future of the PC really a Qualcomm, Nvidia, Project Digits, and AMD Soundwave situation?
I love how the question is framed. It's like, I think the words I love the way that Steve described it, which is a screw shaped trajectory. But I was very, very careful about how I phrased that, and everybody sort of jumps on that. Sort of I was like, no, x86 is not going anywhere anytime soon. It's not doomed. It's as the person who phrased the question there, it would completely miss the point of what I was trying to say, which is, with x86, you have this processor ecosystem now. You have ARM, you had MIPS, you had RISC, like, and the power architecture. There's all these things, going back, if you want to talk about ARM in the beginning with Acorn and everything else. And so my point was that for the server market,
Mm.
uh, starting with the server market, you have all of these sockets, these compute sockets that have um, gone to not x86, and those sockets are not coming back to x86. Amazon was a huge customer. All of their sockets were x86, and then Graviton. And they had, Graviton Zero actually probably showed up with like their RDS system, because remember there was a lot of weird problems with RDS, and it was like, how does this even happen? It's probably bugs in their ARM implementation. And then it was like, oh yeah, we're running this new Graviton processor. That's probably like the second version of that processor. And so Amazon's doing a lot of stuff with Graviton, which is great. You know, low cost, very powerful. It's amazing. Ampere is killing it. Ampere is doing a lot of really amazing stuff to fill some voids that are created, I think, IMHO, by some idiosyncrasies that have existed historically with x86. And also historically, Intel was the 800-pound gorilla. So you have to look at this historically. And Intel was the 800-pound gorilla, and it was our way or the highway. Yes, we're willing to do off-road map CPUs for you. We did a video on the 18 core. There was a really amazing off-road map 18 core Xeon CPU that you could get on eBay for like $200, and that was because when AMD the inside baseball on that was something like this happened. This is my opinion. I'm not saying this happened. Don't take this as fact. But what happened was, Intel or Amazon was getting ready to cut a huge deal with Amazon, and Intel did not want Amazon to do that. Amazon was going to replace a huge number of chassis with the 18 core Xeon with EPYC. And Intel said, don't do that. We will sell you 28 core CPUs for that socket for practically nothing. And they did. And it was a huge number of CPUs. And so the 18 core CPU showed up on eBay. And if you had a motherboard with a certain BIOS, or certain motherboards would support those off-road map Xeons. One of the aspects of the off-road map Xeon was a fixed turbo frequency. It would turbo a little bit, but mostly it didn't. And all 18 cores ran at a certain power envelope and a certain frequency all the time. And those cores were great. And so Amazon, or like ARM, feel that's one of the x86 voids that I'm talking about that is less relevant now because that's more well documented, but turbo is a little bit of a thing. And so like my lived experiences and like what I see in the enterprise and blah, blah, blah is what I'm basing my opinion on that on. Then on the consumer side, that's server. There's a lot happening with server. And so like when we talk screw-shaped trajectory for ARM, we're talking about those sockets are not coming back to x86. But it's also a true statement that there are more x86 CPUs that are on and running today than there were 5 years ago. Both of those things can be true. Is x86 going to disappear tomorrow? Also, not something that I said, but people, man. Anyway,
if anyone understands being taken out of context, it's me. Don't worry, I get it.
On the consumer side, there's Apple, and it's like Apple has been very, very successful with ARM, and those sockets are not coming back to x86, period. Now, was it this question or one of the other questions? One of the other questions was like, do you think one of the reasons for success on ARM is the ARM customizability? And that hints around one of the things that I was sort of talking about obliquely, which is software and hardware co-optimization probably is one of the components of the future. And if x86 has so much inertia that changing one little thing creates a huge amount of technical debt and strange other behaviors elsewhere, then yeah, it's going to be a lot harder to develop and bring x86 into that future versus ARM. There are hints of that kind of baggage even still today. AMD has CPUs that don't have SMT. Why does AMD have CPUs that don't have SMT? It's in ARM's marketing. Well, it's in Ampere's marketing material. Ampere has some enterprise wins where the most important thing to those enterprise customer is not throughput per processor or compute per dollar. It is workload service latency consistency. And with SMT, if you're looking at a microservice or you're looking at something like that, how long does it take to service a request? Is it a consistent 33 milliseconds? Is it occasionally 38 milliseconds? Is it occasionally 160 milliseconds? Those kind of problems tend to go away on x86 when you disable SMT for certain kinds of workloads. Whereas on ARM, it's just, you can count on it being there. And like the Thelio system from System 76 that I tested in those kinds of like transactional workloads, 128 cores, 3 gigahertz. There's no turbo boost. There's no SMT. There's no, all of that machinery not being there. One, you save transistors, and two, the consistency is there. Now, does that mean the absolute top line performance is there? No. Is it also true that SMT is a huge performance uplift mechanism that you can have that doesn't really cost you a lot in terms of power? Yes. What does it cost you? Some workloads, latency a little bit. Maybe you can optimize that in software. Maybe you can optimize that in the operating system. Maybe you can optimize that with scheduling. Red Hat and OpenShift have done a lot of that under the hood, which has been folded back into the Linux kernel for a lot. But there's all these sort of running threads to try to deal with those kinds of things, different kinds of technical debt. And x86 can't be all for everyone, and perhaps the customizability of ARM is one of the things that will help ARM displace more x86 sockets. But certainly ARM in general, and Ampere specifically, Graviton, Ampere, Qualcomm, have displaced an ungodly number of x86 sockets. At the same time, I have specific criticism for Qualcomm in that as many x86 sockets as they have displaced, they have displayed an amazing naivete about how it works in mobile and just video drivers. And it's like, where's my DirectX qualified video drivers there, Qualcomm? I mean, let's get it done. Why with your partnership with Microsoft, literally drop, like, Microsoft put the we couldn't have properly working x86 NPUs because all of the developers were working on everything Qualcomm to bring you AI PC, and there was still a fumble with that, and
they couldn't have been given more softballs to make themselves succeed.
And with all of those developers working on Qualcomm and Windows, we still didn't get DirectX and properly working gaming stuff. Like, come on, really, come on.
Yeah, I mean, I was told but by both developers who have tried to make their games work on Qualcomm's APUs on Windows, and a few other people, actually some people at Nvidia, so they're biased, but that a major reason it seems like ARM doesn't work on Windows, they think, isn't because it is really fundamentally hard to do anymore. It's just because Qualcomm's driver teams just were not up to the task, especially when it comes to their graphics drivers for games. And so I think I want to take that actually as a chance here to pivot into something I told you I wanted to talk about, which is that a bit ago, I leaked that NVIDIA's working on laptop APUs. They showed off that Project Digits thing. From what I can tell, that's actually probably a Skunksworks project of an APU family for laptops that they were working on, and they just put that out early. I've recently actually heard that there's some sort of like voltage and noise issues with these, I guess they're now called Spark APUs, working in laptops effectively, that they're still trying to fix. But I was wondering at Computex when they didn't, not that I was told that this would happen, but I know there were rumors about it, and it's been long enough that I thought they might be true, that they might show off NVIDIA branded laptops with NVIDIA ARM GeForce APUs. And that didn't happen. Instead, they showed off a rebranding of Digits called Spark. And I started to wonder to myself recently, like, have they canceled this? I mean, what's going on because of those issues I heard about? But what I'll put on screen, and I sent this to you ahead of time for people, is, I mean, I have someone, who tests NVIDIA APUs, and they have it, and they have documentation saying gaming laptop APU, like 80 to 120 watts, trying to launch by Q4 or 25 or early 2026. It doesn't, nothing fundamentally that interesting about it, because it really just looks like Project Spark. But I wonder what you think about the fact that NVIDIA's had issues with getting this done, but they seem full steam ahead. What you think about NVIDIA, not Qualcomm, entering the Windows APU market and competing with Strix Halo?
I think that if this is on NVIDIA's roadmap, I think the executive in charge of it missed an opportunity to wield an amazing cudgel
Mm.
to get their laptop out there. I think that if there is some evidence for digits having its root in what's now Spark, having its roots in a theoretical NVIDIA plus Windows on ARM laptop, and I think that Microsoft was very sensitive to um, that pre Qualcomm, like pre the Qualcomm ARM launch thing. Um, and maybe that's from past experiences with NVIDIA SoC or past experiences evaluating NVIDIA products for the gaming division. I don't know, but I think that when Linux. So like again, going to go back to my Ampere system. My Ampere system with in NVIDIA GPU, first class experience.
Mm-hmm.
SteamOS,
Yeah.
like SteamOS, even emulating not SteamOS, but like Steam on Linux, emulating x86, running games. It's like I'm just gonna go in Steam and I'm gonna download a game and I'm gonna run it and it's gonna work. Basically, does work for a lot of scenarios, and so I think that Nvidia, their product manager, could have had a team of like 4 or 5 dudes put a thing together to show gaming on Linux
Mm.
on Proton on the Linux distro. Maybe it probably would have been a little bit more of an uphill battle to get SteamOS working, to get that working, and then go to Microsoft and be like, "Hey, we're launching this with or without you. You want it to run Windows? Otherwise, we're going to run Linux."
Mm.
And then also have that product team get in contact with Valve and be like, "We're doing this. What do you want to do? We heard a rumor that you're going to let SteamOS run on non Steam Deck hardware. Would you like it to run on an ARM handheld laptop?" And Nvidia could have scared Microsoft into compliance,
Mm.
as maybe Nvidia has a reputation of doing, and that they didn't do that, or maybe Nvidia is not that dumb, and so there is a missing piece of the puzzle here, because if they wanted to own the ARM laptop market, I believe that they could have done it. I believe that Nvidia is already in a position with silicon and everything else that literally the only thing they needed was Microsoft buy-in. And even if they really wanted Microsoft buy-in, they could have gone the Steam route and just said, "Hey, V 1.0 of this project is just going to run Linux," because
Mm-hmm.
Linux plus Nvidia is already a first-class experience on the Ampere platform. And so I imagine that there's a prototype machine somewhere in the bowels of Nvidia that is just it's like what is it, like the Grace super chip or whatever, with some PCIe slots, and just like boom, there you go. At Computex we saw the Grace Blackwell like workstation thing. It's got 4 PCIe slots.
Mm-hmm.
Just shove another GPU in there. It's like, again, that's probably going to be a first class Linux experience. Maybe not in a laptop form factor, but um, the Spark thing, I think the problem with Spark was it was really interesting, because apparently it works fine over the network, but beyond that, it's like, oh, we haven't gotten everything else enabled, and it's like, what else is there to do? Like,
Yeah, that surprised me as well. I've heard people have some issues with it doing anything besides exactly what they showed you it doing, which is odd. You would think if this was going to be some play for a supercomputer mini PC that you just have it work at doing everything. And it seems like they kind of only have cutouts at things they want you to use it for.
I would I told some people um when I was looking at the specs and uh what the possibilities are, and I said, this could be the ARM desktop thing. Like, this could be a catalyst for an amazing Linux desktop experience plus ARM, plus you got your little LLM thing, and you really need to not screw this up. And so maybe they're trying to build a truly first class experience instead of having it be a $3,000 Raspberry Pi experience. I don't mean that in a necessarily disparaging kind of way. It's just that when you buy a Raspberry Pi, you know you got to roll up your sleeves.
Mm-hmm. And some of the other stuff you said. So tell me if I'm wrong. Like summarizing what you're saying, like anyone who thinks that they were probably working on this ahead of time, the fact that your Ampere system with Nvidia has absolutely no issues seems to suggest that they have been planning this for a very long time, and that there must be something else wrong if they haven't done it yet on laptop. Because with Qualcomm, I would argue maybe not flopping, but some might argue they did, compared to, again, the massive just opportunity Microsoft gave them, that it's odd they didn't like buy now, just try to swoop right in where Qualcomm didn't take off. Like, that's odd to you.
Yeah, it could be that Nvidia is looking at their margins, and they would look at the margins of, like, your typical laptop margin is like 5%,
Yeah.
and so Nvidia is looking at this, and they're just like, we could do this, but is anybody going to pay a significant premium for less silicon and less? So maybe we don't do this immediately, because if you look at Spark, it's like that amount of silicon is also about the same amount of silicon you'd want in a laptop. Are you going to buy a $3,000 laptop that looks like Spark? Plus, you got screen and all the other, your BOM cost is going to be significantly higher. You can ditch the QSFP stuff, you ConnectX stuff, but does that really is that really a cost versus all the other hard costs for everything else? And so I don't think that non-cooperation by Microsoft would be the only blocker. I mean, certainly Microsoft was more obsessed with the whole Qualcomm thing. And certainly from NVIDIA's vantage point, they were looking at this and it's like, Qualcomm is not going to be able to deliver an ARM laptop that could game as good as we could. But maybe it's a question of margins and a question of, like, do we really want that market? Because per unit silicon, we would be better off selling the silicon elsewhere at a significantly higher margin than in a laptop, unless we just want to take over laptops.
Yeah, that's a funny point you're making too. Like, you can see that Blackwell was at least rumored. I heard it too, that they could have launched gaming Blackwell, I mean, half a year ago. Or at this point, we're already in May, more than half a year ago from now. And it was just all, can they get, the data center and the AI mega Blackwells out. And then eventually these gaming GPUs come out with very lackluster driver support, and maybe Project Digits. And again, I don't know this, but I'm just guessing. Kind of started as an offshoot of this APU plan, but the more the AI bubble grows, the more they're like, why would we put any effort into finishing our laptop plans until it's clear the AI bubble might pop soon? And then we can swoop in and pivot to this, and that's our new thing. But until then, I mean, find a way to turn these laptop APUs into an AI supercomputer so we can charge $3,000. I think that's a compelling argument for what they might have been doing so far.
Yeah, I mean, it's hard to know really, but it would be fun to have that running it as a background, like a background project. And even if Microsoft wasn't on board, you could go just the pure Linux, like SteamOS route, because the plumbing's basically already there.
Chris Rich writes in and he says, let's say that Nvidia launches an APU using ARM in GeForce on day one. It can run 90% of all games on Steam. Do you think that's good enough for gamers to want to buy Nvidia laptops in volume? Would Nvidia need to undercut x86 with GeForce laptop pricing? What should Intel and AMD do to counter Nvidia's push into laptop that is supposedly going to happen eventually?
I think that, I mean, it's sort of becomes a self-answering question, don't you think? It's like, okay, is it good enough? And it's like, well, that's certainly better than the Qualcomm experience that people have enjoyed so far. And the Qualcomm laptops haven't been significantly cheaper than their x86 counterparts, owing to we want to build a compelling experience. In terms of Blackwell gaming performance, most of the Blackwell gaming performance is owed to AI and software features over the 4000 series. So what's compelling there again?
Yeah. Well, speaking about that, though, Gregorius Acker writes, and it says, hi, Tom and Wendell. Based on the current hate NVIDIA has, in my opinion, deservedly heaped on itself with poor pricing and even poor execution of the last few GPU launches, I'd like to pose a question. They have already achieved major victories in dropping performance per tier, while at the same time raising prices per tier. Let's say hypothetically that all the consumer pressure going on right now works on Nvidia. Finally, they relent and they start doing exactly what the minority of vocal gamers have been screaming for, but at the same time, they continue to reap massive profits from that AI bubble on the side. What does a maliciously compliant, if you will, Nvidia look like? Or is that who we have already been dealing with? What kind of products do they try to sell if they don't have to keep two fingers crossed behind their backs as they make gaming products? Will they continue to keep two fingers back there also?
I don't, you sent this question over ahead of time, and I don't really 100% understand what they're asking for. I think,
So I think what he's saying is, I think here's an easy way to characterize part of it. Like, we're all mad that the 5060 is 8 gigabytes. We're all mad the 5070 is 12 gigabytes. It seems ridiculous, that they're doing that. And that, for example, I think the 5070 has like less than a third, almost a fourth the CUDA cores of the 5090, whereas back in the day, it would have been half to 2/3 as many or something, depending on the generation. Like, if NVIDIA takes to heart this idea that they really are just milking too hard. And I mean, look, even if it's just whatever it is, single digit percentage of their revenue, that might just start going away if they keep treating people this way. Like, what is the version of this generation or future ones where they're willing to just accept that there's a limit to how much margin they can pack into these gaming cards? Like, where does that stop? And what would an NVIDIA look like that starts playing ball with what we want a little more in gaming?
I think, I think just not treating the customers like morons is really the most malicious compliant thing you could do. I mean, so I have no problem with, I think Steve kind of said this at the end of his video. There is no shame in or anything wrong with Nvidia. I think Nvidia would actually be better off just not selling anything less than like a 5080.
Hmm.
Like, just if you want something less than a 5080, buy last gen's card. I mean, there's not. Why is that? Why do we have to play some sort of Machiavellian game where
Yeah,
we
like
convince
Porsche
ourselves?
doesn't make a $20,000 entry level car.
Yeah, yeah, exactly. So why bother? Like, it doesn't. I mean, maybe for mobile, it's like maybe you need a 5060 that can fit in a mobile chassis. Maybe there's some argument for that. But if 4090 is equal to a 5060, like, I mean, it's like saying my 80 mile per gallon go-kart is the same as last year's Toyota Camry. It's like, I don't think so. I don't. That's not a great analogy, because the 4090 is actually pretty nice. But I think the 5090 is nerfed. I think the 5090 should
Mhm.
have been 48 gigabytes. I think the 5080 should have been 24 gigabytes, and we'll probably get a 5080 Super that's probably going
Yeah.
to be 24 gigabytes. I think that perhaps the fact that the Blackwell RTX Pro 6000 is also 600 watts is a sign that maybe Nvidia themselves didn't quite get the performance that they were expecting out of Blackwell in those contexts. But look at the margin between 96 gigabytes versus 32 gigabytes on a 5090 is not worth $8,000, but yet that's basically the price difference between, or $6,000, I guess. MSRP is like 8,500 versus MSRP of 2,000 between the 5090 and whatever. And so it feels like Nvidia was trying to give game, if the MSRP is truly 1999 for the 5090, that seems like the deal of the century compared to an $8,500 96 gigabyte RTX 6000 Pro, when the performance is basically the same. Yeah, RTX Pro's got some more ROPs and shaders, but it's basically the same card. And they would be better off. Look at it as like the shareholders would be looking at this and be like, "What are you doing? Get out of the gaming market!" Like, every 5090 you sell is an RTX Pro 6000 that you don't want to sell. And it's like, I get that you want to do lip service and marketing to gamers, but like, stop. It doesn't, like, you're smothering the market for other companies that could do something interesting in terms of gaming innovation. Right now, the fundamental proposition is that you want to convince gamers to buy less silicon and make up for it in software. And you're telling gamers, like, our software will make up for it in silicon. But I think the more honest thing is you can't afford the silicon. We're going to try to give you an experience that's not unreasonable in software. And it is actually surprisingly good. Like I had because you have games like Cyberpunk that force on like TAA and like multi-frame gen on the 5090 in with Cyberpunk on a 240 hertz OLED. Oh my gosh, like I can't, like the actual gameplay experience, it was shockingly amazing. And so I logged some significant time. I played more games around the 5090 launch with the 5090 than I have in like a year. And it was really shocking in a bad way when I went to like the 5060 Ti and it's like, let's enable multi-frame generation
Yeah.
and like try the same kind of stuff. And it was like, oh, this doesn't feel good at all. This isn't
And that's probably
amazing.
why AMD's taking some market share, right? I mean, most people buy the cheaper cards, and maybe for a few gens now, they've been seeing this isn't a good experience anymore, even though Nvidia wants to pretend it is with your, your 5 fake or whatever amount of fake frames they're at right now, going from 30 to 120.
It I don't know. It's there's a lot of people that are buying at the low end, and then after you buy, it's like I'm going to convince myself that I'm not having a bad experience because the
Mm.
FPS number is really high. But just it was nowhere near as good of an objective experience, even though like the frame rate reported was like still kind of high-ish. And yeah, you can fiddle with the settings and it's like end up dialing the settings down and doing whatever. But if you take multi-frame gen off the table, then Nvidia is really and you take all the competitors off too, then Nvidia is really competing with last gen. And um like 4070 is a better experience than 5060. Like it starts to not look super good. So I don't know that Nvidia's Halo effect. I don't know that the gamers really understand that, but like that's the honesty, and like that's the being honest with gamers is like, look, we're just not going to do this at the low end because nothing works right at the low end for to give you as good of an experience. So buy a 5080 or a 5090, and less than that, just go for last gen.
Yeah, I think something's going to have to give on what I'm about to bring up, which I often hear from people at NVIDIA. Like, because every now and then NVIDIA will be aggressive with some card. And I'm like, well, why are they doing this? Why are they bothering with this? And it's always like, there's an ego thing here where Jensen doesn't want to lose ever. And he knows his company was started with GeForce. And because of that, he just can't get away from trying to still dominate gaming. And he's trying to balance what you said, like giving less silicon, but arguing their magic AI software makes it the same as AMD's, with just this really doesn't make sense for them to bother with anymore. And I wonder when that will give, or if he'll just say, nah, it doesn't matter. This is a, I don't know what it would be for like maybe like a car company who spends all this money on like an F1 or like some of these special cars that really doesn't make sense for them to do. Like it's some kind of crown jewel thing for them. But whatever they do, I just think, like you said, stop treating us like we're stupid. Just because I'm going to kind of skip Christopher Mullen's question here, but it was like asking about like, would it be better if companies just charge more and don't pretend what we're buying isn't what we're buying? Like, I think, like, why doesn't Nvidia just call the 5060 the 5050, call the 5070 the 5060 Ti, and maybe make it $500? And like, we know we're not getting a 70 class. And I wonder, like, if Nvidia might be a little less greedy, but then finally do, in my opinion, and it sounds like Steve would agree as well, do themselves a service and just not lie about what they're selling. Like, look, the 5080 is really a 5070 Ti, but we're charging $1,000. Into investors, you could go, look, we're charging $1,000 for what AMD would have to charge $600 for, and we're not even going to pretend anymore. Like, I wonder what you think about that, because I keep thinking, like, just call the 5070 Ti the 5070, or even 5060 for $600. I mean, yes, be a little less greedy, but like, if you can get away with charging $600 for a 5060, does it matter if it ties the 9070 XT?
Eventually, somebody is going to do a comparison that goes back to like the 2080 Ti and like the 1080 and the 1080 Ti, because there are people that are still getting like the 1080 Ti is not a terrible card in 2025, and there's going to be someone that goes back to like GTX 580 versus 2080 Ti, because the unit time delta from A to B. And then they're going to get to the like 5060 and 5070 versus, a similar
3060.
yeah, and it's just like, wait a minute, what's going on? Something went really wrong. But it is, to your other point about the gaming stuff enabled um the whole CUDA ecosystem, and then from there sprung everything else. There is maybe an aspect of like R&D. It's like, are your gaming customers your R&D customers? Is there overlap for that? How does it work? There's also a little bit of overlap too. I think about the ARM aspect of this is like that. Those sockets are going. Those sockets are never coming back. If you want to think about it even more generically, uh, which silicon today is doing the compute? Like, how much compute is happening on planet Earth right now? Floating point, integer, doesn't matter. And how much, like, who owns the silicon that is responsible per unit compute? And x86 is now just like, it's this very tiny little slice of all of the compute that is happening on planet Earth. And everything else is GPU. Now, not necessarily Nvidia, but also AMD and also ASICs and also, like Cerberus.
Qualcomm, you could argue, is a significant percentage.
Qualcomm, Apple's
Yes.
GPU aspects, but like not even their cores. And so it's like most of the compute is happening on not those kind of cores anymore too. So, I think that things have evolved, and to an extent, some of this is just hanging on to the legacy, like the legacy gaming aspect of it, and still wanting to like, win and do something interesting for gamers. And I went into the multi-frame gen thing like super skeptical. Like, I was like, this is going to be like terrible. But like the upgrade from DLSS 3 to DLSS 4 was shockingly good. And multi-frame gen I find to be less good. Multi-frame gen I think is more akin to like DLSS 1.0. It's like, there's maybe something there, but it's really fundamentally a smoothing technology. It is not a replacement for raw compute. And if you game on a 5090 on an OLED display that is absurdly fast, and then you game with the same, not the same settings, but like the same sort of like, I want to use multi-frame gen, and I want to, at even at lower resolutions on an OLED, it just can't. It doesn't feel the same. It just can't keep up, and things it's just not the same, and it's not as enjoyable. And the peak frame rates are nowhere near that. Now, if I'd been gaming all day on a 1080 Ti, and I go to that, I might have a different opinion. But stepping down the stack is like, it feels like there's some driver bugs here. It feels like the 1.0 drivers, where it's just like you got some micro stutters. It just doesn't
Or
feel
drivers
right.
from graphics cards from just 15 years ago, where we didn't know it at the time, but they were all micro stuttering all the time, and we just were used to it. I mean, go back and try Fermi. It's funny what we used to think was smooth, is what I will tell people who just got into PC gaming. But you touched on something that I think is interesting too. Is like, could keeping, I don't know, Nvidia is at somewhere between 70 to 90% of the gaming PC laptop market or whatever. Well, I guess not laptop if we include APUs, but desktop, a dedicated graphics market. Do you think some of that's kind of like an insurance policy? Because I feel like when AMD was falling apart a decade ago, that AMD's stranglehold on Xbox and PlayStation, and even then eventually the Steam Deck and a few other little consoles in China, that was kind of an insurance policy that no one's going to stop supporting Radeon and AMD CPUs because actually half of the gaming market uses them still. And maybe there's something here where it's like you can't really measure it, and there will always be number crunchers that try to argue it's not having a big effect. But like, if most gamers on PC, if most god tier rigs have NVIDIA GPUs, NVIDIA knows deep down that will have a massive PR influence on when NVIDIA is used for everything else. Because in people's they associate NVIDIA with leisure and happiness and just playing their games. And the second that goes away and they're just seen as like a server company, is there a PR loss here? Like, even if the AI bubble pops, they know they can leverage their gaming market share into some new thing, you know?
No, I don't think so, because Nvidia is already doing that fairly effectively. Um, and that is, they want to reposition themselves as an AI factory. They want to be, it's like, we're going to produce tokens. The
Mm.
tokens are going to be the thing that powers AI. The people that are buying this kind of stuff, I don't think there's a halo association with Nvidia. I think there is a little bit of inertia in Nvidia because of the market position and the market cap and like everything that has brought them here now. But I think that in the beginning maybe it had, you know, the gaming aspect of it, but now I think that Nvidia is positioning themselves to be known as not just an AI company but just a compute company. And now from GTC onward is like, we are a factory for producing tokens, which, okay, sounds good. It's like everybody needs a factory to produce tokens in the way that every company needs a source of electricity. That's how Nvidia sees themselves and sees themselves evolving. And so in terms of marketing and everything like that, it's like, why do you need to market electricity? It's obvious how you're going to integrate it into your company, and if it's not, you're not going to be around as a company anymore. um, so, you know, it's like, we're going to burn coal and do steam the way that we always have because this
Well,
electricity thing
some people
is
still seem to
bad.
think that, to be fair, it seems.
Yeah.
But so you think that no, it maybe is just like an ego, and like, no, we just are used to winning gaming, and that's why they continue to try to contort themselves like a game of Twister into making this 50-60 that really should be a 50-50 at best be called a 50-60. You just think it's because it's what they've always done.
I think that the launch of the 50 5000 series and the general reaction to it, if it is internalized at NVIDIA, there's probably some serious conversations going on that are like, maybe we don't, maybe the 6000 series literally is just a pro card and like one or two high end gaming cards, and we just don't bother with anything else because why would we?
Or at least, yeah, and this is something they've been kind of doing gen over gen, if people pay attention. Like, God, let me think of like when the, at least going back to when the 1000 series, before it probably was even more so like what I'm describing. It was 1080, 1070, 1060, and then pretty quickly after that there was the 1050 Ti, and then, you know, so on and so forth. And I mean, I think before, back in the day, they would do launches with like 580, 570, 560, 550 Ti. Like, they would have most of the lineup launch within a certain amount of time. And over time, I mean, I remember when a lot of people thought it was crazy the 4070 might not launch with the 4000 series, and they even had that lineup. Remember, where they revealed the 4090, the 4080, and then they were just like, and below that, buy last gen, like, and everyone complained about that. Like, so they've already kind of started it. Like, it might just be a thing where like the 6090 launches, then the 6080 launches 6 months later, and then a year and a half later they actually finally launch the rest of it, and only because the previous gens have finally sold out. It's just not a priority whatsoever.
Yeah, because again, per unit silicon, especially if it's like an older process and blah blah blah. Blackwell's a little different because the process isn't really different. It's just a new design, um, I guess, or whatever. But it would be interesting to see, if in those discussions that are happening internally at Nvidia, that if they're looking at the, like, I would go back all the way to the 3000 series, because it's like the 3000 series, because they were facing, like, AMD was giving it their all. And so it's like, okay, there's like four versions of the 3060 or five.
Oh,
And
the
then
3080 12 gigabyte 3080 Ti, you know.
yeah, or maybe it was the 3080 I'm thinking of. It's been, it's all fuzzy. And then remember the card that they unlaunched, the 4000 series, and
Yeah.
it was like, oops. It was literally like, do we have the memory of a goldfish? A lot of the complaints from the 5000 series is literally almost how aspects of the 4000 series launch played out. And again, if you're looking, if you're an executive and you're not, you know, you don't have like the gaming heart, and you're looking at it, it's like, why are we bothering dealing with these bozos? Like, we just sell six more RTX 6000 Pros and just laugh all the way to the bank.
Yeah. Yeah, it'll be interesting to see what they do. This piece of content is brought to you by JLC PCB and their Transparent Flex PCB products. In addition to supporting traditional yellow, black, and white PCB materials, JLC PCB now also offers transparent PCBs. Imagine the visual experience electronic products can offer when they shed their bulky enclosures and use transparent PCBs as a foundation. These have high optical clarity with 85% light transmittance for superior visual performance, excellent thermal stability, withstanding temperatures up to 200 degrees Celsius, SMT assembly are compatible with fully supporting surface mount technology on transparent substrates, and they are cost effective, offering 30 to 50% lower price compared to typical market rates without compromising quality. You can get these PCBs for $5.80 and get a $10 coupon for Flex PCBs at JLC PCB through the link below that supports the channel and also gives you the best possible pricing on these excellent products. So please check those out to support the channel. And thank you once again to JLC PCB for sponsoring this content. Let me ask this. Join Patreon X6999 writes and says, how are the Nvidia drivers faring with professional work? Gaming side, it seems like it's a complete mess for Blackwell right now. But has this been the same for other applications with their professional variants? Also, is this ROCm push because of this with the gaming side of Nvidia maybe arriving at the best time possible for AMD?
Certainly with the Blackwell Pro RTX 6000, which I got and it's retail, it's not sample or anything like that. And it was like the first one off the boat, and I sort of sensed a certain amount of nervousness from Nvidia with that, because I think there is definitely a lot that I uncovered that is let's call it software unreadiness. There was a lot of like CUDA 12.9. There was a lot of unreadiness with CUDA 12.9. There was a lot of unreadiness in terms of performance optimization for things that are floating around in the cloud. It's like, things kind of would work, or you could like download a model and you could kind of run some stuff. And it wasn't like pants around ankles disorganized and discombobulated, but definitely it would be alarming to me slightly if I were doing certain kinds of things, as long as theoretically, as long as Blackwell has existed. I would not expect CUDA 12.9. I would not expect downloading and running certain Docker images to have been as rough around the edges as it has been. Not to say that it's a bad experience. I mean, everything, like you let it run and it do its stuff, and it's pretty good. And it was definitely the right move to move from 80 gigs to 96 gigs of VRAM. And so there are certainly some things that have gone down well in terms of engineering, but like I don't think Nvidia was even able to get these cards into their own engineers' hands quickly because of demand and everything else. And so it could be that some of the people demanding the demand already have their software stack figured out based on whatever, and they're running it. But generally, in terms of performance, I've had a better experience with CUDA 12.9. But wanting to use CUDA 12.9 with all of the stuff has been a little rough around the edges. But they're also fixing it really quickly, because it's like just getting back from Computex, and it's like I look at the Git history and it's like, oh yeah, they've made a lot of changes. So I think they're quickly dealing with it, but there's definitely there's some cracks that are showing here, I think. And
even in professional, then the cracks are showing
just a little bit,
which is crazy for them, because you'd think it would be at the expense of gaming that the professional side doesn't have any issues. But we keep coming back to it. It just seems like it's like, no, their goal is to get their stuff into the hands of AI developers who maybe have their software stack already figured out. Everything else isn't even second. It's like fourth place in terms of what they care about.
That was another aspect of the thing that I didn't understand from Jensen's speech, is that he's on stage, he's like, oh, we got the H100, but we can't give them away. Everything is like Blackwell is setting the stage for everything going into the future. And he's probably not wrong about that, but I guess it has been such a huge software engineering lift to move from H to B, that is, the cracks that I say are showing are really are not cracks. They're just more like the concrete hasn't dried yet. But if you look at the like what's going on in the cloud is like, oh, here's H200 or here's H20 and here's our cloud provider. We're going to do this, and it's a little misleading because then you look at the the Hopper infrastructure and you get some performance numbers there, and it's like, okay, this is pretty good, but like Jensen was saying, it's like when you get all the software enablement for the new Blackwell architecture, it's like it's going to leave Hopper in the dust, which I think is probably true. It's like, oh, sales doesn't want me to say this. Remember from his
Mm.
presentation? Uh, so I get why he's saying that now, kind of, but also I think that for some of the software stack here, there's still performance on the table for Blackwell.
Yeah, it's funny you say that too, because I remember some contacts I have in like the professional space who, when they saw how they were just told, and this was, during mining booms and shortages like 21 and 22, like, oh, you gotta get the A100, don't wait for anything. Who cares that we're charging extra? Just buy it. And then they saw how much better Hopper and Lovelace were. Some people I talked to were mad at Nvidia, like, well, we're not buying this. It has the same amount of RAM. Screw you. That maybe they're learning from that as well with Blackwell, where they're like, it's better, but you can still buy Lovelace or something.
I think there were more than a few Hopper orders that were canceled after, if there were delays or whatever, and then so then Blackwell happens, and it's like, oh yeah, Blackwell's legit.
Kiln God writes and it says, Wendell, how do you feel about ROCm coming to Windows? Personally, I'm excited to wrap ROCm in C hashtag, Jesus, for GPU acceleration with C hashtag other than CUDA. When will you be publishing PyTorch and other benchmarks of ROCm versus CUDA on Windows?
So I got an amazing interview with Andre from AMD, and that's going to be on the channel
Mm.
probably the week of the last week of May, first week of June. Um,
So that
and
good timing for this then. Good plug.
yeah, yeah, he had a really interesting answer for Windows native first party for ROCm and PyTorch, and that is because I don't want to. I need to internalize what he was saying because it was very information dense. But my impression, my memory, which may not be perfectly accurate of what he was saying, is that he really feels like that there are enough developers out there that want a truly first party experience that could be useful and competitively differentiating for ROCm on Windows for AMD, because he doesn't feel like that other developers are currently experiencing that in terms of like what maybe a little bit of what we were talking about earlier in terms of like, oh yeah, just use WSL and get your experience with WSL. And it's like, no, I think Windows is a first party. Like we should try to make this a good developer experience. There's another really amazing GitHub repository you should check out under ROCm called The Rock. And so under ROCm, The Rock, this is the tooling for ROCm that you can build yourself. And guess what? Strix Halo. It's like you can build that and then get ROCm, and so you can get a lot of truly first party ROCm goodness with the Rock to build the tooling and build the platform, the Gen 2 of ROCm experiences, if you will. And I was really worried about ROCm like 6 months, a year ago, but there there are a number of new chess pieces that have appeared on the board, let's say,
Mm-hmm.
and the Rock repository exposes that if you're into that kind of thing. And when you see what they're doing, you see the trajectory that they're on with the Rock repository and what they want the ROCm experience to be for CDNA and RDNA and a future theoretical product that might be UDNA, where we've unified the family. They might just be building the Death Star. And so
Right
that could be
now.
pretty.
Yeah. Yeah, no, I didn't mean to cut you off. I was just kind of trying to add on there. Is like when and let me say, I've heard a lot of people a year ago, a lot of, and again on the professional side, people complained about ROCm a ton. But you're saying like maybe this has been slow and steady, and they're slowly merging towards like UDNA, ROCm support and features, and all of these other things at the same time. And it's like just boom, kind of surprisingly overnight, AMD will have some compelling packages that no one saw coming.
Yeah, it's almost like you're working on, somebody says, we're going to go to Alpha Centauri. And it's like, they make really amazing Starship hulls. And it's like, well, I mean, okay. we could probably build a space-faring vessel out of this amazing metal that you've got. But I mean, come on, we're going to need artificial gravity. We're going to need matter antimatter reactors. We're going to need like what do we? And then you look over here, it's like, oh, I didn't realize you were working on the artificial gravity plating. That's working. Oh, I didn't realize that over in this other place you had matter antimatter reaction going. That's also working. As well, crap, we've got all the Legos now. We just got to put it together.
Yeah, that's funny too, because I at the same time I do often hear people say like, oh, I just tried ROCm with this one thing or this one feature for AI with a 7900 XTX, and all of a sudden it works perfectly. I can say that this is nowhere near the same thing, but like me with editing and rendering and just professional, just kind of, making thumbnails and videos and that sort of and special effects stuff, that like with RDNA 2, my memory was it didn't even work. Like rendering videos, exporting videos. They're like, it's for gaming. We haven't finished that yet. And then I was on Nvidia for a few years and I just tried the 9070 XT. And then it's just like, oh, wait, this is as fast in a lot of apps as my 4090. What the heck? When did this all happen? But I guess it's all been happening here and there over time where they've been catching up on the software side.
Yeah, it's a really interesting trajectory, and it's really RDNA is shockingly good for a lot of things in 2025. And part of me thinks like there's still a lot of work to do. Like, don't get me wrong, but again, I'm sort of optimistic. It might be another one of those Lucy football situations again. But it looks like this is going to be pretty exciting. And given the fumbles around 5000 series, it's like, I don't know, this could be good.
Yeah, I mean, the thing I brought up to my friends recently when we were playing the aforementioned Helldivers 2 was I was talking about, which we'll get to soon, like Zen 7 and all the stuff AMD's working on, but then we eventually talked about RDNA 4. And I was like, the thing, and I've got some friends that are like, well, NVIDIA's messed up so much with Blackwell. Of course, RDNA 4 is doing well. And I'm like, I don't know how long you've been around. There's been times where NVIDIA just face planted and just outsold Radeon like 4-1. That's not necessarily true. And sure, NVIDIA messing up is part of why AMD's doing well right now, and AMD doing everything right is part of why they're also doing well. But I don't know that I ever thought I'd see, at least in the short term, AMD having their RDNA 4 cards sell above MSRP, where NVIDIA's are selling below MSRP, especially in Europe right now. That's crazy to me. I mean, that means you're starting to see the brand value of Radeon catch up to Blackwell. A lot of it, I think, is the driver issues. I think that was the secret bullet, whether it was true or not, every gen that NVIDIA had. And that AMD seems to have really captured something here, whereas I may have been a little disillusioned a few gens ago that AMD would ever catch up. But I feel like I'm starting to see something happen here where I could see AMD actually getting to 30 or 40% market share now. Something's happening here, I think. Possibly. I don't want to be optimistic. I've been bitten before, but
I think so as popular as like the GTX 1060 and 2060 are, I think that if the MSRP situation was not screwed, that would be the 9070 XT. The 90, like people would be buying the 9070 XT in million unit quantities if the pricing, the actual obtainable pricing were closer to MSRP, because it looks like it's got all the stuff needed for a GPU for that kind of longevity. At the MSRP price, it's got the price, but it's also got the RT performance, but it's also got the VRAM, but it's also got PCIe Gen 5, but it's also got upscaling and all those other features. And so at that price, it has that kind of legs, I think.
And I'm curious, I have to bring this up because it was just announced at Computex, but what do you think about the 9060 XT, 16 gigabyte? Because when I saw that, it was, I put out leaks and stuff. It's at the upper end of the performance and the aggressive level of pricing I was hoping. It almost looks more interesting to me than the 9070 XT. I mean, it seems like you're going to get probably at least 7700 XT, but with 16 gigabytes performance for $100 less than what the 7700 XT was. I know everyone likes to talk about the high end, but giving people something that seems maybe not quite there, but pretty close to PlayStation 5 Pro performance, for half the price of a PS5 Pro. I mean, I remember when graphics cards were cheaper than the consoles that they beat, and this could be a huge, I feel like, catalyst for like the RX 580 and 1060 people moving over to something they've been waiting for years.
Yeah, the pricing. Well, I mean, don't know until we actually like do the benchmarking and do the other stuff.
I agree. I agree.
But you know, the MSRP on that is also really, really aggressive, and so that's another. I think that's another one. You know, another round that AMD has for possibly getting a GPU with that kind of longevity, like you say. The ship may have sailed, and it may be because of board partners, or maybe just because of the global macroeconomic situation or tariffs, or I don't know. And so the ship may have sailed on the 9070 XT, and this could very well be another. It's like we got to go super aggressive on the pricing because we know that MSRP is not going to be real for one reason or another, board partners or just the reality.
I've heard a lot of them will be above MSRP at launch. I'll say that. I'll probably do a bigger report later, but I've heard that at least at first, and I think personally half of it's that they just can't make enough of them. I mean, I keep telling people if AMD is 20% of the market and Nvidia disappears like they have seemed to, then AMD would have to make three times the GPUs they usually make just to get to 50% market share. Like that's a tall order. So I think what I've heard is over time they expect the pricing to gravitate towards MSRP, but at first it's going to be a struggle to keep it at MSRP because of demand.
Yeah, and it's still, you know, for just what they've shown with 16 gigs of VRAM, it looks like it'll be a pretty aggressive situation for gamers, which is great. But it would also be nice if the 9070 XT gravitated toward MSRP sooner rather than later.
Yeah, it seems like it is a little bit, especially in Europe. But I mean, I just checked Micro Center, and I guess what I can say is you can definitely find them for $750 or less now, but they're not $650 or less like we would probably hope they'd be. The 9070 XT, that is.
I think the other interesting aspect here is what Intel is doing, because Intel's cards have gravitated toward MSRP almost immediately after the 9070 XT launched, because they were trading really high too, and it was just like, what? And then the 9070 XT launches, and then it's like, oh, it's like $35 to $50 above MSRP now. So that's interesting.
Yeah, I mean, on the Intel thing, the perfect time to launch anything would have been right now because Nvidia is not servicing the market. But I mean, look, if it launches after everything has, after supplies met demand, I think it'd just be Alchemist all over again. Let me ask you this. Bespoke exclamation point writes in and says, "Good day, gentlemen. I guess this is more of a question for Tom, but I really want to hear Wendell's input. Have you heard or do you think anything of all of the FSR Redstone updates will be included in PSSR 2 for PlayStation coming next year? According to Mark Cerny, the TOPS performance of the bespoke RDNA architecture in the PS5 Pro is actually similar to the 9070, and I believe higher than the 7900 XTX. So in theory, it should be possible to do it with their architecture in a different way. And I'm kind of curious your thoughts on like it's like a weird RDNA 3.54 hybrid in the PS5 Pro. I forgot which one it was. It was int 8, int 4 versus FP4 or FP8. But like it doesn't have one of those in the PS5 Pro. And so they'll have to do it differently than how RDNA 4 does it, but they have much more of that than what RDNA 3 had. So it seems conceivable. But I'm wondering what you think about this like interesting different way of doing things that Sony's started to do, but also in partnership with AMD and like where that's going.
I have no idea. It's hard to predict because on the one hand, I think Sony also wants to sell you less silicon and do more stuff in software.
Yeah, maybe. Yeah, I mean, or at least they're going to charge more for it, as we've seen with the PS5 Pro, right?
They're looking at in Nintendo, and it's like Nintendo is buying the swill flash that they normally only use for the lowest bottom rung USB flash drives.
That's what I've heard of people in the console space too that I've spoken with, is they're just like, there's got to be a degree where they're looking at Xbox raising prices of the Series S to the same price almost as a PS5, and iPhone selling for over 1,000 and going, why can't we be greedy?
I mean, it's got to be just eventually it's just like we need this to be a low latency cloud streaming device, and then we don't even have to sell you compute.
I think that's
Like,
Microsoft's plan, to be honest.
yeah,
Yeah.
yeah. Uh, it's not good.
Well, if you don't have much to say about that, though, let me ask you about a different APU. Webby, not Wendell. Webby writes in and says, "Hi, Wendell and Tom. I'd love to hear your thoughts on Strix Halo, which we've been dancing around, and how similar chips will shake things up going forward. Is there any chance we might get a socketed version? Is the unified memory going to make lower end discrete GPUs obsolete eventually, in your opinion?"
Yeah, again, the gaming performance on this is absurd. The 8060S, which is part of that's in here, it's just, yeah, it's absurd. It is absurd gaming performance. And part of that is also, like, don't forget, your memory bandwidth on this platform is like, I was getting 217 gigabytes per second under Windows.
Mm-hmm.
I mean, under Linux, and that is absurd. Like, remember, on a normal like AM5 desktop platform, your best case scenario is on the order of 100 gigabytes per second. And so for large language models, memory bandwidth is the thing. For gaming, APU, like VRAM, memory bandwidth helps a ton. So it's yeah, power efficient. It's like, I would like to run the CPU at 7 watts. Okay, we can do that and get reasonable performance. Also, 16 cores.
Mm-hmm.
My goodness, what a crazy situation. So yeah, to the last question, do we just get to a point where there's no? I mean, obviously it takes more transistors. The processor has to cost more. Will there be, you know, like the 9950G with the 8060S? Sure, maybe, possibly, probably. Um, and does that replace low end GPUs? Yes, it absolutely does.
Yeah, they can, I don't think they can fit it on AM5, but some of the early things I'm hearing about AM6, I think it's going to be a little bigger. It wouldn't surprise me. There's multiple reasons you'd want to make AM6 a little bit bigger of a socket than AM5. Certainly fitting higher core counts for desktop and having all these other options moving forward would be nice. But there's a part of it where you could make it just big enough, right, where some version of their Halo chips over the next 5 to 10 years they could bring to desktop and then say, all right, we're done. They could even maybe do whatever it's called, the 11950X, but then have an 11950G as an alternative offering for those who want that. And I do think eventually, to be honest, I'm surprised they haven't done it yet. I wonder if they will. Like, I've heard Zen 6. Was it Zen 6? Yeah, Zen 6, you never know. They've played around with the idea of having 8 RDNA 4 compute units just in every desktop chip. At that point, you're already at like 30, 50 performance. Like, I think at some point they're going to at least do this thing where they're like, okay, now there's literally no point in us making sub 200 GPUs anymore, right?
Yeah, I mean, it's certainly been a transformative and informative experience getting Linux running on that, and playing, like, I was playing Clar Obscura on the airplane ride back from Computex at 2880 by 1800 on that display, and that is with upscaling and all the
Sure.
stuff turned on. But it was a pretty glorious experience, and it was just like, I can't believe this works as well as it does. One, on Linux. Two, the performance it's every bit as good or better than a 4060M, which is, how is this possible? What was the first part of the question? The first part of the question was something different, I think.
I believe he said, how else will things like this shake up? What other things will products like Strix Halo shake up moving
Oh,
forward? And do you think we're going to get socketed versions, which we already kind of touched on too?
I think so. I think that the trajectory for this is that if you look at mini PCs and how popular mini
Mm-hmm.
PCs are, and like the mobile, and like AMD has their other, it's a 12 core. I think it's 4 Zen 5
Yeah.
cores and 8 Zen 5C cores. Um, if you look at that kind of stuff, I think that this could supplant the low end desktop market entirely.
Yeah.
So not so much even the GPU side of things. Is just like, I'm going to buy an AM5 or an AM6 system or whatever. There's literally nothing below like 12 or 16 cores. Not because that's the natural, not because 16 cores is low end, but it's because if you need anything lower end than that, you're just going to get a motherboard with a mobile CPU. Because
That's what I'm
the,
using. I have a Minis Forum 7945HX 3D motherboard that was like $600, the price of a CPU by itself, and you get the cooling, the motherboard, and actually has some high-end features for an ITX size, hard to come by with AMD sometimes. And my brother just built one with something similar. My friend just told his friend to do something similar with like a $450 motherboard, 16 cores, everything included. I already am having a hard time recommending getting any of these socketed motherboards when you can get, for the price of a single CPU, the whole package, and you add a GPU. I think we're already kind of there.
yeah, certainly on our forum and some of the videos that I've done for deal hounds, it's like if you want a deal hound CPU configuration, the mobile CPUs with X3D, it's hard to beat. It's hard to beat.
And I mean, like, and I could see, like, when it comes to sub $800 systems. I mean, I know I've got a Strix Point system here that's just this big. It comes with 64 gigabytes of RAM and all this other stuff. I know you also tested the minis for MSA too. I've got one of those workstations here as well, where I'm like, if they made it this much thicker, you could just put a full graphics card, not a thin one, in it. And if that was $999, why would I tell anyone to get anything else for an entry level system?
Yeah, exactly. It's like you're giving up some stuff because it's entry level, but the stuff you're giving up doesn't have anything to do with the compute and the compute experience. The stuff you're giving up has to do with, like, you're gonna have to buy a USB hub, but it's still
Sure.
got 10
Yeah.
gigabit ports. So like, just get a 10 gig hub, shove, and put all your stuff on the 10 gig hub, and then you still probably got another 10 gig port or two instead of having 12 ports on the back. It's like, yeah, I know it sucks not having 12 USB ports on the back, but look how much compute you're getting. It's glorious.
Yeah, and I think for the people that would do an entry level system, they probably don't need 10 USB ports.
Everybody needs 10 USB ports.
Well, of course, instead of just using one modern thing, I've got to keep using my stuff from 5 years ago, or sorry, 10 years ago at that point. But I'm curious though. This is something I kind of brought up with Just Josh on a recent episode. They kind of danced around a little bit. I'm curious how you would answer, like, when you say it's blazing fast gaming performance, it's incredible, breathtaking to game on the APU. How much of that is, the average, hardware unboxed lines on graph, it's up here and that's a high number. How much of it's that, and how much of it is the ease of use? Because I think last time we talked, I had a Hawk Point system that you also had that we were talking about, and like half of it just having like unified 32 or maybe 64 now, or 128 gigabytes of RAM and one graphics card, no other iGPU you got to toggle between, and just loading the game and it works with unified memory. I will trade actually a lot of FPS for that experience, especially on the go.
Yeah, for an on the go experience, there's a lot to like about that because you don't have, I mean, if you have 8 gigs of memory dedicated to the GPU, and then there's a GPU chip, and then there's a lot of things that are the enemy of good battery life. Whereas everything is unified here. Certainly, that's been a thing with the Mac side of things. It's like, oh, you get built-in graphics, but Mac has a lot of memory bandwidth. So the mobile experience is objectively better for a lot of reasons around quality of life and things like power integration beyond just what you're describing. But what you're describing is also a benefit. And so for a mobile system, yeah, sure, that's as a system architecture, that is the most optimal system architecture that you can run, because if you're not doing anything graphically intensive, that memory is still going for cache, or it's still going for applications that you're running, or it's still going for whatever. I don't think the unified, like a truly unified memory architecture driver thing is quite there yet, especially on Windows. But as good as an experience as it was on Linux and everything else, and reasonable frame rates, yeah. And the frame rates are, I mean, you could 40. It's about on the level of a 4060M. I'm trying to think of like a desktop counterpart, and it's weird because you could have a desktop counterpart that would have
Like a
more
7600
FPS.
XT or something, 7600 if it had enough RAM.
Yeah, but it's different though because it's an APU, so like you can get a higher frame rate but worse texture
Right.
quality, or better texture quality, and the same frame rate, and there's some weird.
Just
Some
turn
weird
down some of the settings, and you'll actually be gaming at 200 frames per second, no issue.
Yeah, but the ceiling on like if you turn everything all the way down to like nothing, the APU is still not going to give you an absurd frame rate just because latency and memory bandwidth. Whereas even a 7600 could give you, like an esports on like super low everything. It's like, yeah, you're going to get 200 FPS, but you're never going to get 200 FPS out of it.
So you like have a higher floor and a lower ceiling than what you would get out of
Yeah,
other things. Okay.
yeah. So it's I mean, not necessarily. It depends on the game and some other
Yeah.
parameters. But I was noticing, like in real world, like my real world gameplay experiences, like, oh, that's kind of interesting that it is kind of a lower ceiling, higher floor scenario with some games. Some games it's still going to be like 12 FPS. It just depends. But for reasonable gameplay settings and reasonable visual fidelity, the actual experience was fantastic, shockingly good, way better than I expected from an APU. And so, yeah, 2 or 3 generations from now, something like that, it's like you're not. Why would you even? Why would you do anything different?
I'm curious why it was shockingly better than you expected, because, and maybe this is just me, maybe I'm an idiot, I don't know, but like I see 40 compute units, I see 16 cores, and I go, who cares if it's an APU? It has higher specs than that other desktop card, and it should give me better performance than that desktop card with
Yeah.
lower specs. But like, was there something about it that it did well? Because it sounds like there might be. That why would that have surprised you given the specs?
Well, on paper, there have been similar specs proportionally gen on gen going back in time. What also worked correctly was all of the accoutrement around the experience. So it's not just the raw compute. Like suspend resume didn't fail me. I used the HP G1A as my daily driver, 128 gigs of memory, and Strix Halo, and running Linux Arch with the guide that I did on the forum. And not one time did suspend resume fail me. Hibernate, it's like, oh, I've been suspended for 30 minutes. Let me go ahead and hibernate. That worked correctly 100% of the time. The fingerprint sensor worked correctly like 99% of the time. It's like, oh, let me use the fingerprint sensor in Linux, and like this actually worked. I'm just going to launch a Steam game and like start playing, and I'm going to close it, and nothing crashed, nothing was weird. There wasn't weird display corruption when I scrolled. I got to enjoy the 120 hertz OLED display on that particular laptop, and the gaming performance was really good, and the MediaTek Wi-Fi mostly was working correctly by the time I got the kernel 6. I think it was like 6.16.6 or 6.14.6. It's like bleeding edge Linux kernel with bleeding edge firmware, and it's got a couple patches on it, and so that I've never I'm a Linux enthusiast, but again, Lucy football, whatever. It's got warts a lot of the time, and it's like I can look over those warts, I can work through those warts because it's me, but it was a basically wart free experience, and almost all of the warts that I would complain about were attributable to the drivers for the ISP webcam being out of tree, the fingerprint sensor being a little sus sometimes, which maybe I need to train on more fingerprints, and that's basically it. It's like suspend and resume working right every time. I don't have that experience on Windows with any laptop.
Why do you think that is? Do you think it's because it's an expensive piece of hardware, so they actually did their homework? Or do you think that there's something fundamental about having a unified driver and software stack for just one, like having less components to worry about in the laptop?
Probably less components to worry about is an aspect of it. So the last time I had my laptop get hot and not turn off in my bag, when I debugged it, I figured out that it was Teams. And so it was like, oh, well, obviously that was my fault for not closing Teams. Obviously. So, because Teams has a new behavior now where when I exit Teams, it's like, oh, you mean go to the tray?
Yeah.
Like, no, I meant exit. And so that happened in that scenario. And it prevented the laptop from sleeping. So it got hot and ran the battery down in my bag because, of course, Teams, of course. And even though you can run Teams on Edge and Linux, in Arch, there's a little thing where you're like, you can run arbitrary other commands. And it's like, yes, run this command to forcibly suspend all Edge processes. Problem solved.
Yeah, that's a thing though that, and again, I could go on forever about the Microsoft app stuff. Skype does that too. It did. It's gone now, except it's not. It's Teams. Um, like that's something I tell people too about if they're deciding, especially in the low end. Do I get this $800 laptop with like a 3050 and whatever, or do I get this Hawk Point or entry level Strix maybe Kraken laptop? And I'm like, can the APU run your games at 1080p 60 low medium settings reasonably well? Which most of the time it can now. If it can, I'm just telling you, an APU only laptop will have less issues. You're going to be surprised that when you click the sleep button, it does sleep. When you fall asleep holding your laptop, like I do, because I use it like a tablet at night, and then I wake up, it has battery life still. It didn't just drain. It just turned off the screen and somehow still 80% battery.
So in the
That's what
ROG
you're getting.
Flow, it did not suspend and resume 100% reliably on Windows, but on Linux it did.
This piece of content is brought to you by the fans that support the independent journalism of Moore's Law is Dead on Patreon. And it does need supporting, from personal attacks from tech elites that get mad when we tell you that they are lying to gamers and their own shareholders, to legal attacks from mega corporations that cost the team time and money. This is expensive and often very stressful work. And it's work that doesn't depend on access journalism, nor depend on NDAs or agreements that would sanitize our opinions and hold us back. No, nothing holds us back, and we are independently funded, and we use said funding to do things like pay professional renderers to show you products before they come out so that the sources that provided us the original pictures don't get in trouble. Or we also create bonus content like Die Shrinks, where you have videos and interviews coming out multiple times a month exclusively to reward our patrons with the extra content that we know they would like to see, whether it's inside scoops or more in-depth conversation and stuff that we just know wouldn't profit if we put it out publicly, but it doesn't need to profit for our fans on Patreon because it is self-funded. And so if you want any of that bonus content, or you want to support the independent journalism of Moore's Law is Dead, or honestly, if you just want to support me, Dan, Gerard, Carbon Cry, or Jesse and Maurice so that we have food on the table every day, consider supporting Moore's Law is Dead on Patreon. And to those that already support us there, I'll see you on the Discord.
So, anyways, though, speaking of laptops having issues, I actually wanted to, we were going to do this early in the video, but I wanted to, but we talked about other stuff, and I want to make sure we eventually get to it. Raptor Lake failures. I looked at the last recording we did together, and over a third of the conversation was about all of the Intel Raptor Lake instability issues. I mean, I heard there's this big ring bus flaw. You put out this huge video that had really a lot of evidence and sources backed up behind it, kind of proving that this really is a problem Intel's having with Raptor Lake systems falling apart. Developers came out and said, we can attest this is a problem. There's multiple developers, to my understanding, that warn you when you have a Raptor Lake CPU that if it crashes, don't blame the developer. And yet, here we are, almost exactly a year later. And I mean, that became a big issue for Intel. It did. But at this point, it's Raptor Lake. Although, from what I remember, the sales did fall apart for a while there. They are now outselling Core Ultra. Now, I don't know if that's just because, in general, Intel sales are down, and so whatever, you're beating Core Ultra in sales, it actually doesn't mean anything for Intel, relatively speaking. But I will say, I have asked people in retail, and they say, generally speaking, the ones that still carry Intel, which a couple of them even stopped for smaller mom and pop shops from this, but like, they say that the issues are much less prevalent, even if they seem to still be there to a degree. So maybe a lot of their mitigations eventually are working. But do you feel Intel's done enough to address the Intel Raptor Lake failure issues? How do you feel about the fact, too, that like this isn't really talked about anymore, even though I still see articles popping up about Intel putting out these patches that nerf performance on Raptor Lake to I think as of this month or a month ago to this day. And did you foresee this happening, that Core Ultra would eventually lose in sales to Raptor Lake?
Well, I didn't foresee that Core Ultra would lose to Raptor Lake. I do think that, and I covered this pretty well in the launch video, is like the pricing was not super compelling at launch.
For Core
and
Ultra.
For Core Ultra, yeah, and it does seem like the pricing has been adjusted, because I was just looking at I was at Micro Center a couple weeks ago, and I don't know if it was a one-time sale, but it was before Intel announced an actual like $100 price cut or whatever, or I saw a press release. It was like, oh, Intel
Yeah,
quietly
the
cuts.
desktop Ultra 7s, and at least the desktop ones, yeah, they did.
But at Micro Center before that, so I think probably to some of the retailers like Micro Center, you could get a board and CPU combo with the Ultra 7 for $300.
Mm-hmm.
And it was not like a top shelf board. It was an inexpensive board, but it's like, that's a pretty thumping good deal. The Core Ultra 7 is not that bad, especially for that price. So modern architecture, blah, blah, blah. But yeah, I thought it was pretty funny in Intel's shareholder call that they said, it's like, oh, we're still selling an amazing number of older CPUs. Part of that, I think, is the warranty. The only thing that I think that Intel really has missed the boat on here still is that there's not a tool to run and detect the issue and report on the issue with your CPU. If nothing else, Intel should do a tool that reports the telemetry of your, like the model specific registers, characteristics of your CPU, serial number, and it's like, do you know the batch and lot number? Is that attainable from, like, can you query the CPU and do that? And even if they don't want to report it, like whatever the utility does to run it and figure it out. I would point you also to Oodle's blog post. They just posted a couple weeks ago or a few days ago or something, where they were figuring out where exactly the crash was in their code. And they have a pretty compelling argument that there is a little bit of clock stretching going on that doesn't stretch enough in some scenarios. And so the pointer address counter gets written instead of like the actual contents of what's supposed to be there, which is what the instruction is supposed to do. So instead of the instruction writes the length of something that it's supposed to copy instead of the thing that it's supposed to copy, but it does it intermittently, which suggests that a clock is not completing in time, which is maybe a clock stretching problem. Or that circuit is particularly sensitive to degradation or whatever. And that is interesting. It's not a software bug; it's definitely a hardware bug. But it is very, very interesting. Still seeing a fairly, a number of failures for 13th and 14th gen in the data center, but it does seem like the firmware updates have helped tremendously. The most recent performance impact, severe performance impact mitigation, was from a security issue, not a fix for the errata. But if you're a cynic, you might say they were saving some of the best performance nerfs for the next security nerf. And so the security nerf gets the security nerf and the performance nerf. And it is significant in some scenarios. So, but this is more of the performance nerf. It's not unfair to say that the performance nerf is more security related than anything else. It's somewhere between 0 and maybe a little bit, but maybe with the security nerf, it's still the balance of the performance loss is due to the security issue, not anything else. Even if you believe that they stuffed an unrelated performance nerf to try to prevent degradation in there. Interestingly, the number of people that have shown up on our forum and in messages complaining about KS failure rates. I don't know. I have very little data on non-gaming motherboards with the KS, and the KS failure rates seem kind of like they're still happening.
Yeah, I would believe that.
But it does seem like the rate of failure has decreased sharply. I think it's also interesting that it was basically proven to be workload dependent. So if you are running Y-Cruncher 24/7, that generally is not going to degrade your CPU. If you are, however, running Minecraft with 1 million bots, that's going to degrade.
That's
it's just like,
interesting.
wow, that's interesting. Yeah. If you're running, but with amazing exceptional cooling, like your cooling is way above whatever Intel expects what your cooling is going to be, then the better your cooling, the worse off your CPU is.
Because they'll burst higher, and it's the voltage level, not the heat, that's the issue. Yeah.
Yeah, and then the instability creeps in at the low end instead of the high end. So it's a very interesting and weird situation. But you got a long warranty for that CPU. You know, just keep getting it replaced over and over again. What's not to love?
Yeah, I guess I can see why. I think it's twofold like that. Like Raptor Lake coming back and outselling Ultras. Raptor Lake, let's be honest, has become incredibly cheap. I mean, I remember pointing out like how bad it seemed to be getting for Intel sales on like Amazon best CPU sellers were like, whatever, top 10 or even top 8 or 9 out of the top 10 are all AMD. And then you'd see like an i5 there selling in the top 10 every now and then. But if you check the price, it was like $140. And I'm like, that's the only reason that i5 is in the top 10 is they're selling it for half of MSRP. And that's not necessarily a good sign for Intel that that's what it took to be one of the top 10 selling CPUs on Amazon against AMD. So I think there's a degree to where it's like getting cheaper too. But I think another part of this is, I don't know. I mean, I don't think anyone cares about AI in their laptops. I've asked many retailers, like, has anyone came in and been like, it has to have AI? And it's like, no, I want this many cores and whatever. And the reason that hasn't hurt AMD is, I mean, AMD put AI in the title of everything they sell now 3 times, I guess. But fundamentally, Strix has 12 cores, not 8 cores and a hot point. And, it has a stronger graphics card and everything else. So while they do talk about AI, if you look at it on paper, you would want to get that. But if you look at Lunar Lake, it's just got 4 big cores. And a lot of people, whether it's fair or not, I know the little cores aren't weak, they're not going to buy that for the AI. And they're going to say, this is 4 cores, that is 12 cores. I'm going with AMD. But I don't know. I wonder if you agree with that a lot of this just seems to be that the whole AI is everywhere initiative just didn't work.
Yeah, no one wants Copilot
Mm-hmm.
still, even though Copilot is relaunched. It's like, oh, AI PC. Qualcomm's going to give us the AI PC because Qualcomm is a big part of that whole line. No, it's not going to be a thing. And from that Micro Center trip a couple of weeks ago, it really stood out in my mind because you could get the Core Ultra 7 285K and a cheap motherboard, and it was $299. And now I think just the CPU by itself is $249 for the Core Ultra 7, and that is a
Mm-hmm.
thumping good deal. Like, you would be crazy to not to. But they also at the same time had the 12700K with a motherboard and 16 gigabytes of RAM for $320.
Mm.
And so it's like 16 gigs of RAM, but it's just like, why? Wow, is that? Because I would rather have the Core Ultra 7 285K than a 12700K in almost all scenarios. But I thought it was wild that the 12th gen was also still selling as well as it was in the Micro Center sort of context. But the Core Ultra 7 doesn't have an NPU or anything like that either. But
I think it has a 16 or a 10 tops one, right? Not one you're ever really going to use. So, but yeah, I think a problem with Arrow Lake is it needed to be at least 10% faster. The problem is you have Zen 5 X 3D, and then you have this pile we'll call everything else, like Alder Lake, Zen 4, so Zen 5 actually is aging pretty well above Zen 4, so maybe that's not quite fair, but at a minimum, Zen 4, Alder Lake, and every Raptor Lake and Core Ultra, they all seem to have the same performance, so like it's just a race to the bottom in pricing if you're not the best. And I guess people might just look at Alder Lake and Raptor Lake and go, that's the same thing, so I'll pay less for that. I would agree. I would probably want, once we're getting to Alder Lake, like I would get I like Alder Lake for super budget systems, but if it's only going to be like 10% less, yeah, look, I'm going to get Arrow Lake. That seems ridiculous to me.
Yeah, exactly. It's just like on the used market and all the other stuff. I forgot. So the other part of the whole NPU thing is like you're right. Actually, now that I sit and think about it, it's like 13 NPU tops, but Intel does the GPU tops as well. So it's like it's 20 tops but it's what's insane is we just had MS Build, and there's a lot of news that came out of MS Build, and like DirectML is not really like that. Also didn't catch on and was not really that didn't work out the way that Microsoft really intended, and so I think they've pivoted there as well on what they intended. They wanted DirectML to be like DirectX for machine learning, but to make it easier on developers, because again, brass tacks, if you're a developer, is like, what are you going to do? Support 17 different platforms with 17 different implementations. Like, no, you need something like DirectX. Like that was the whole point of DirectX. But that not only has that not caught on, we haven't even bothered to do a software platform that makes sense. I mean, there's Onyx, I guess, but
yeah, and it still shocks me. Like, one of these mini PCs with Strix in it here has a Copilot button built into it, and you can see now in Windows Task Manager your NPU, is it being used? The answer is no. It is never being used, even if it's a powerful one for an APU, relatively speaking, and it's always just going to the cloud with Copilot. I don't remember who said this. I think it may have been just Josh or something. A recent guest brought up to me, like, the reason is if you look at the quality that they need for decent AI assistance over the cloud. We're talking about data centers of graphics cards, and the reason almost no he argued the reason almost no developer is probably using Copilot locally is it's not powerful enough to do almost anything you would want it to do locally, even if they told you it would be enough. I wonder if you agree with that, and maybe that's why it's not catching on.
Yeah, I definitely agree with that. There are models out there that are 7 billion parameter models that are perfectly usable and good to run locally. But more context, you need more and more sophisticated tasks that you might have that are on not as well trained a model. Just having a higher parameter count model is a faster way to have a cheaper model to do that. I think Microsoft in their vision for this is that they're going to stop paying for this in the data center. They want your computer to be able to do this locally. You're paying for the electricity. You're running the compute. And hell, they might even be able to run some cloud background tasks on your computer eventually to be able to do these kinds of things, to service requests. I think what like everybody's already screaming that no, that's not going to happen. But I think what happens is advertisers, Microsoft effectively rents time on your computer to advertisers to be like, this person is probably going to be interested in these products. Let's figure this out. And so directly or indirectly, Microsoft is paid by advertisers to have stuff run on your computer to figure it out as opposed to the cloud.
Oh.
And that completely changes the cost calculus.
So like when it loads a web page or in app, the ads that would be targeted at you, it's using your local NPU to decide instead of, wow, that'd be very maniacal, but I could see that working out financially. Yeah.
Well, Microsoft believes that is in your best interest to do that. And it's like, wouldn't you rather, I literally have, it's not, wouldn't call it AI, but I mean, for the better part of a decade, I've had Python and other scripts running to like trawl eBay and Craigslist and things like that for things that I'm interested in. And it lets me know. And, if things go on sale on Amazon, it lets me know. And so having a conversational agent in Copilot to be like, hey, Copilot, if you see this thing on sale anywhere, let me know. And it
something like that.
Could tell it conversationally, and that's just always running. When I put it that way, it's like, oh yeah, that'd be fine to run in the background on my NPU. But I mean, it's going to be done more sociopathically than that in the end. But that's what's going to happen.
Yeah, that's interesting. And it's like, but right now, anytime I install Windows, I check the box, do not want targeted ads. And it's not because I fundamentally care if they're targeted. It's not even about the data. It's, I don't want them pinging a server, wasting my processing power to target the ads,
Notice how the fine print there says you won't change the number of ads you see.
Mm-hmm.
It'll just be less relevant to you. And it's just like, yeah, that the same amount of compute is still being burned. It just might not be yours. You might be doing somebody else's comparative analysis. I don't know.
And they'll try to find a way to have that checkbox remove some feature you do want if you don't check it, so that you do it.
It wouldn't be the first time that Windows Update completely changes your preference. It's like, oh, did you mean to check that? Oh, my bad. I'm sorry. Android does it too. On my phone, the power button recently became the AI assistant button, and it's like, I didn't invite this change. I should be able to sue the company and recover monetary damages for abandoning my preferences.
All right. The final thing I really want to pick your brain on, at least briefly here, if you have the time, is about Zen 7. A week ago, I put something out, actually, while I was on vacation, so technically it could have come out sooner, that talked about, and I have screenshots showing this from documentation I was able to share, I mean, look, Zen 6, they're going to tune N2X for consumer, which is crazy to me. Like that, not just N2. Not just N3, not just N2, N2X from N4 with Zen 5. But then Zen 7, apparently a year and a half or whatever it is later, plans to go to 1.4A, 264 core servers, and is, of course, aiming for, we'll see if they achieve it, who knows, 20% IPC increase. But another thing that was really crazy is this 3D core thing that, frankly, I'm kind of surprised they haven't done already, but it's exciting they are eventually here, with like 33 core EPYC chiplets. And then below that, a layer of not just Vcache, it's its own chiplet layer of 7 megabyte L3 cache slices. And I believe they're removing the L3 on these 3D cores from the core chiplets to save space and then just 3D stack all of the cache right under it. I think that what's fascinating to see here is like this movement to Zen 6 that already looked aggressive. And then after that, it seems like two product cycles in a row, they might go to the newest node before Apple and do all of this 3D stacking stuff. And the way I concluded this with like High Yield, who was on a recent episode, was it just seems to me that fundamentally AMD's done beating around the bush here, and they know they've got performance crowns, and they're just going to do what Intel has been doing, like with 3 nanometer with Arrow Lake versus AMD's 4. They're going to buy the newest node. They're going to use the newest node with their newest architecture, and they're going to keep going bleeding edge. I'm wondering like what you think about anything I just said, but then additionally, I wonder what you think about them going to higher core counts for consumers, because I actually have some reservations about if that will matter that much.
I don't know. I have no idea what to think about Zen 7. I mean, that seems like that's we're just about to get Zen 6, and so it's just like my brain is focused on like, what are we going to get with Zen 6? It seems like a lot could change between now and then, first, but second, I think that the design of operating systems has already been changing to support larger and larger core counts, and that we'll probably see consumer operating systems adopt something that like we've already seen from the hyperscalers and from things like what Red Hat OpenShift does, which is the sensitive processes and the operating system accounting processes basically run on dedicated cores. And then you don't have like security mitigations and context switches and this kind of thing go away to a certain extent. And so user land processes being on user land cores and system processes being on system cores maybe is awesome from an operating systems design standpoint, and maybe is awesome from like a software implementation standpoint. I think the real thing that is going to enable just bananas performance in the future is going to be very, very close hand in hand software and hardware co-development. So like kernel optimizations that are designed specifically for x86. And certainly we see that with like EPYC and Tim Sweeney being on the x86 advisory board for like how they're going to do x86, ISA changes and that sort of stuff, is another vote in favor of the whole like lockstep hardware and software architecture, and whatever is needed to support that in terms of like cache slices and sizing and optimization from an operating system and process management standpoint. If that's getting folded into silicon, then that's great. I think that none of that can ever really be done in a vacuum, but the more close knit the operating system and kernel people go with the hardware silicon architecture, the more it's going to benefit users, whether that's cloud computing or end user computing. The benefit for the end user is going to be tremendous. But in terms of like these specific changes to hardware or like things that are, rumored to be a part of Zen 7 or whatever, I mean, it's fun to speculate, but I have no idea.
But so you touched on like security, like, well, once we have all of these cores, we can just assign system tasks to these cores, some of these cores, and boom, half your security issues are fixed. I'm wondering like how many cores do you think that would take? And you want to talk about Zen 6? Well, might be in Zen 7, but it's already supposedly going to be in Zen 6. These low power cores that are fundamentally the same cores. They just massively optimized for smaller, use less energy. A similar idea to what Meteor Lake did with like their low power E cores, but fundamentally different in that they're not E-cores. They're low-power Zen 6 cores that can run any application with a reasonable amount of IPC and clock speed. Do you think they could just run system operations on
Oh, yeah.
those cores?
Yeah, sure. I mean, that's not a problem at all for that kind of stuff. I mean, that's great. You know, even Intel's Lunar Lake, I think, had there's one Lunar Lake design at least that had two ultra low power cores, and then they had like their E cores, and then they had four E cores, and then there was like two performance cores or something like that. And this is different because this is all the same Zen if they're going to do it like the compact versus the performance. So that's even a better situation in terms of software and context switching and that sort of stuff. But yeah, having having some cores that are basically dedicated things, and especially like if there's the cache is segmented or sliced or whatever, and it's like, oh, you accidentally can peek at some other process's cache, and it's like, no, you can't because it's physically not there. Then a whole class of security issues just goes away.
Yeah, I've never thought about that. And this was in context to Epic for the 3D cores as well. It makes you wonder if half the reason they're doing this isn't performance, but segmenting this, I mean, that could just create a whole new level of security for their customers.
Yeah. Yeah. It sounds like a modern design, a nice hardened modern design where everybody's out to get you. It's like, hey, you got AIs fuzzing your processors, and it's like you don't have any secrets anymore.
So one last thing about this, though, that I'm curious, because I imagine you'll have some thoughts on this. I mean, even Zen 6 is planning to go to just 24 cores. I've heard Zen 7 may go to higher core counts on a larger socket with AM6. I already alluded to that with you. But like a lot of people I've seen complain, gamers, you know, we went from 4 cores to 8 cores, and then we went to 16, and then to 16, and then to 16, and then to 16. And then they're like, why are 16 core stagnation? This is the same as Intel with Skylake and Kaby Lake. I don't think it really is, because 16 is still a lot. But how much of like this move to 24 and 32 cores for consumers, how much do you think consumers are going to go, oh, the people that bought the 9950X are going to buy the, I don't know what it'll be called, the 10960X 24 core? And how many people who are rooting for higher core counts on desktop may have only been doing so because they thought it would make everything else cheaper at the same core count level? And look, I think it will to a degree, but I don't think you're going to get 10 cores for $200, people. I mean, how many people do you think once the 24 core, and especially if there was a 32 core land, do you think people who were buying the 16 will actually buy those? Because I'm going to be honest for myself here. I wanted 16 cores over 12 with Zen 2, and I still have a 16 core now. I'm very happy with it, but I'm very happy with it. I don't know that I need 32 cores on desktop. I did need 16. I don't need 32.
The thing that has surprised me is that as much as the performance has improved with a single core, it still hasn't improved enough. And if you look at I/O and you look at, so I'm going to build a NAS, and I want my NAS to be 25 gigabit, let's say. How many cores am I going to have to use in order to keep that single 25 gigabit pipeline fed? And the answer is not a single core. A single core has a lot of trouble keeping that 25 gigabit pipeline fed. This is something that happened in Windows relatively recently. 25 gigabit works basically flawlessly in Windows today, but a couple of years ago, file sharing stuff on Windows by default was just a single thread, and so you were severely limited by your single thread speed for just doing file copy operations, unless your NIC also did RDNA, and then you could kind of mitigate it a little bit with jumbo frames, because with jumbo packets you have to deal with a physically smaller number of packets because they're all bigger. But then sometimes your GPU or your network card could offload that, and so it didn't matter because then the CPU wasn't dealing with it. It was an ASIC on the NIC that was dealing with it, and then it didn't matter much between 1500 or 9000 byte, except for it was less overhead, and so you could get some more of your overhead back. But a single core has trouble with just like basic tasks like just I/O. Like it physically can't move enough stuff. If you do a memory bandwidth benchmark with just a single core on a modern x86, like on a modern AMD or Intel CPU, it is a pathetically small number. A single core has trouble moving a lot of stuff, and that's one of the places where Apple excels, is like a single core can access basically the entire system's memory bandwidth. What? Yeah, kind of. And so if the system, and there's not a lot of pressure on system architecture to improve single core memory bandwidth, except for that end users would probably notice that, but there's not, like, from a commercial use standpoint and a server use standpoint, increase a little bit, but it just doesn't need to increase dramatically. And so those kinds of things sort of obfuscate how many cores you actually really truly probably do need. Just shuttling data around and doing things like for end user interactive things is like, yeah, sure, does 8 cores get it done? Yeah, probably. But I think that you're probably going to need a lot more cores to juggle everything else between background and foreground tasks, just because the size of everything that you're doing is going to be so enormous.
What do you think people will notice more than, I mean, N2X, which AMD's confirmed they're going to these bleeding edge nodes, at least with Zen 6 publicly so far. Like, let's say they hit, who knows, 6.5 gigahertz, whatever amount more IPC. Let's just call it 10% more IPC. Like, do you think that's going to be more noticeable for even enthusiast users, like going from whatever it is now, I think 5.7 gigahertz Zen 5 to 6.5 gigahertz Zen 6 with higher IPC? Do you think that'll be more noticeable, or going to 24 cores?
I think higher IPC and more memory bandwidth will be the first things that are noticeable, and more cores will be noticeable in longer running tasks and any kind of a task where the operating system is doing a good job juggling background tasks and foreground tasks.
Yeah, I still think it's interesting because as much as some people demand more core counts, what is the number one selling Zen 5 CPU? 9800X 3D. It seems like even if we get more cores, I'll be fascinated to see, like, if we actually wanted them. Someone did, but like if we actually needed those, like in server, sure. Although even some server people I'm hearing, they're like, 128's enough. I don't really need more. Give me more bandwidth. But
there are a lot of people that buy server for, I just need more memory bandwidth or more PCIe lanes, and like 16 cores will get it done.
I guess that's a final question I could ask here too. Someone asked, do you think they're going to add more PCIe lanes in upcoming motherboard chipsets for consumers, or do you think they're going to keep going where they are, where you get, like, I don't know, a few NVMe drives, one full 16 for your graphics card, maybe one for a network card? Because I know that, like, if they did go to higher core counts, the number one thing a lot of people would ask is, are you finally going to give me 32 PCIe lanes instead of 16?
See, I think the system architects for Zen 5 already planned something amazing and magical, and it just didn't happen because of cost or some other dumb reason. And that is, you got 16 cores direct for the GPU, low latency, amazing fast, 16 lanes Gen 5. And then you got 8 lanes Gen 5 for everything else. If you've taken that 8 lanes of Gen 5 and put it in, like, and you had a PLX fan out, I'm like, PLX isn't even the right term anymore because of the Broadcom acquisition. But
I know what you mean, though. Like, we're able to divide it up more.
Yeah, well, 8 lanes of Gen 5 into 16 lanes of Gen 4, and then divvy that up however you want. That would be great. Or even, like, you could have, 8 lanes of Gen 5 and into a mud, because that's what the ASMedia chipset basically does. Is like you get that Gen 4 lanes of Gen 4, and then you got tons of Gen 4 and also Gen 3. It doesn't magically give you more bandwidth, but you can mux all the USB and the SATA and the PCIe Gen 3 devices, and then it very efficiently uses bandwidth. If you were to take, 24 Gen 5 lanes and take that into a PLX, so like we're back to the days of having a North Bridge. You don't want to do that with a GPU because it adds latency. But if you wanted the bandwidth, maybe it would make sense for Epic on server. And so you have a North Bridge maybe in a server context. And then you could have like 2 8-lane Gen 5 lanes and then like 4 Gen 4 X16 slots. And even if you're pegging all of those slots at full bandwidth, you're almost not up against a bandwidth limit into the CPU, which is just bananas. It's just that we're not efficiently using all of our Gen 5 lanes from a data packet perspective.
So yeah, it sounds like you think, forget even AM6, like something that would support Zen 6, some new enthusiast, chipset. We don't need much more. You could add just 4 more Gen 5 lanes, and then if you built the right chipset and platform, you can make that drive significantly more IO sooner rather than later. They just have to build it, and they just haven't for cost reasons.
Yeah, as a practical matter, right now, with the number of lanes of Gen 5 that we have, it is plenty. The problem is extracting it and using it efficiently, because the GPU, your 16-lane Gen 5 GPU, is not using the full bandwidth 99% of the time. Storage, okay, maybe it makes sense to have dedicated lanes for latency and everything else, because we do have 15 gigabyte per second Gen 5 drives. And so like Zen 6, if it has more bandwidth, great. If not, you could manage it with a layer of chipsets, and that layer of chipsets does not really matter for server workloads, whereas it might for client workloads. Okay, yeah, maybe something like that would be nice. To be interesting. The design, I always thought the design for USB 4 was kind of amazing, because it's 4 Gen 5 lanes that would support 4 40 gigabit dedicated Thunderbolt ports, and this is a dramatic improvement over Intel's design for USB 4 Thunderbolt 4, because it's not shared. Like with Thunderbolt 4, you can't even get 40 gigabit. You only get 20 gigabit when you're using it for everything except display scenarios. Like modern chipsets can do a better job. Apple's chipset for Thunderbolt 4 can do a better job, but Intel's OG design was already way oversubscribed, whereas with AMD's, out the gate design was like, you get 1 Gen 5 lane, which becomes 4 Gen 3 lanes, 1 Gen 5 lane, 4 Gen 3 lanes, 1 Gen 5 lane, 4 Gen 3, 1 Gen 5, 4 Gen. So you get 5 Gen 5 lanes here, but 160 gigabits of front end bandwidth into that, which is just crazy.
Which rarely would one thing pull all of that. Yeah.
Yeah. And we're cheating a little bit, because one of those numbers is duplex and the other one is simplex, and so it's a little misleading. But yeah, exactly.
Yeah, we'll see. I wonder how much of this too is like motherboard makers just still thinking they can't spend all this money on making the AMD motherboard that will do all this stuff, unless it's like $1,000. But I guess we'll see. I'd be very surprised, based on what you're saying, that, I mean, if the building blocks are already there, I'd be very surprised if we didn't finally get what we were hoping for when Zen 6 increases core counts then. And I know a lot of people, that, me included, that, like you're saying, like, I've been kind of waiting for a micro ATX motherboard that has all the IO I used to get, arguably with Haswell sometimes, but can't get now, all these USB ports. And I just decided, screw it, I'm going with the Minis Forum motherboard. I'll just put a dongle on the back if you guys won't make the motherboard I want. But it sounds like I'd be very surprised that it didn't change next gen. That's interesting. All right. Well, I think we got through pretty much everything I wanted to talk with you about. I really have to thank you again for the wealth of knowledge you bring to this channel. It really is appreciated. Please.
I'm just an internet rando. A lot of it comes from experience, and like, I may have the wrong idea, but it's a lot of fun anyway.
I can't think of one annoying person in the YouTube comments that starts it with, I may have the wrong idea. It's usually, I know everything, actually. And there are people that do say that, but they're never the mean ones, or the people that try to tell everyone that they're right. But so, no, I think you sell yourself short, but please sell yourself some here. Where can people find you? Come on.
You can forum.level1techs.com, level1techs.com. We've got a YouTube channel. We have a Linux channel also. I've been doing more content for that lately. So I don't know, Level1Techs, whatever. I don't care.
Well, I do for you, my friend. So there will be links in the description where they can find you. And then I will also at least chill myself. Please, subscribe to Moore's Law on YouTube, ring the bell button, tell people about us, comment down below, like the video, subscribe to the Patreon. You can ask us like Wendell questions. There's bonus content. There'll be another die shrink coming out this week just for patrons. And then subscribe to Broken Silicon on your podcast app of choice and give us a review. Set it to auto download on all the phones and tablets you own. That would help so much. And yeah. I don't know. I don't have anything else to say. Thank you for watching, everybody. Thank you for listening. And have a good week, everybody.
See ya.
This podcast was brought to you by the YouTube channel and website Moore's Law is Dead. Moore's Law is Dead and Broken Silicon are trademarks of their creator, Tom. That guy is me, and I am indeed the creator, editor, writer, and showrunner of Moore's Law is Dead podcasts, videos, articles, and other media. However, it's not just me. Moore's Law is Dead is a team, with Broken Silicon co-hosted by my brother Dan, audio editing by Gerard Cortez, renders being done by the industrial designer Jean-Philippe Clermont, and special assistance is also provided by Carmen Craw and Carrie Nosugad as well. Find all of our information at www.mooreslawsdead.com on the About / support page in the event you do want to hire me for consulting work, hire Gerard for audio work, hire Jean-Philippe for industrial design work, or you're interested in working with Carbon Cry or Carry No Sugata as well. You can also find our long-term sponsors on that page if you want to show them some love for putting food on our tables. Or you can also mail us some love. You can send letters or hardware donations to the following address: Moore's Law is Dead, P.O. Box 60632 in Nashville, Tennessee, zip code 37206. Although, to be honest, the best way to show Moore's Law is Dead some love is to support us on Patreon. Patrons are what makes Moore's Law is Dead content truly possible. Every month, and really every day, depending on who you're talking about, me, Gerard, Dan, and Jean-Philippe are working tirelessly to provide a steady stream of content that we could not keep doing unless we knew the work was possible without being reliant on sponsors dictating every little thing we put out. Don't get us wrong, we love our sponsors, but we love directly working for you, our fans, much more. If you have any extra money, even a couple free dollars a month, consider supporting us directly on Patreon. Those couple of monthly dollars will get you access to the exclusive podcast Die Shrink, voting on subjects of future podcast episodes, the ability to ask guest questions, and of course, access to the Moore's Law is Dead Discord full of like-minded people who I am sure would love to meet you. I am one of them. Additionally, higher tiers get access to early, ad-free episodes of Broken Silicon, the ability to ask questions in all Broken Silicon episodes and Loose Ends live streams ahead of the recording, and the entire back catalog of Moore's Law is Dead podcasts, in addition to having thanks in the credits of videos and podcasts depending on the tier, with other perks available as well. And hey, if you cannot afford to support us directly every month, please do share Moore's Law is Dead videos and podcasts with friends and family, and on social media and websites like Reddit, and give Broken Silicon a 5-star review on Apple Podcasts or your preferred podcast app of choice. All of this does really help us so much. But like I said, this podcast would not be possible without the patrons directly providing predictable and reliable support every month. And so now it is time to give a personal thanks to the greatest of the fans. The following supporters are at the 10 gigahertz or higher supported levels:
Brad Medlin, Gina Foles, Z Jits, Daniel D, Dink, Nicholas Buckner, Aaron Close, Jan Rauner, Daniel Hyde, MJB1, GZ Ziggy, Toka, Compressed AI Blocks, SNES Chalmers, Jem Ferriero, Velcom Alev, Jensen Wang, Gregory Ass Acker, Sarcastro, Chris Rich, Evan Dingle, Halbuma, Shredbird, Sammy Malas, The Boss Haas, Chrysantine, Jonathan, Amiable Chief, Neith Zinc, I Should, Jake Dude 23, Jake Martin, Zlicky, Meat and Pork, Tim Robb, Ian Clifford, Gamers Unite, Travis Gooding, Mad, Zootsuit Taylor, Greg, Michael McGee, Patty Cake, Stephen Coates, Mark Mitchell, Tommy, James Anderson, Mark Rainmaker, Cole Addict, Cameron, Henry Zhang, Wesley Sager, Michelle Pell, Wen Wang, Hexapuma, Reginald Ari, Teak Autumn, Windstar, Corey Leonard, James I. Raider, Little Germany, John Swin, Shay, Milton, Melodic Warrior, Brett Jones, Chuck Glennon, Mac Daffy, Stephen Dick, Justin Bustle, Austin Haggerty, Joe Foot, Brian Scanlon, Hardland, Jansen Angima, Joseph Kelly, Slushba, Him Sagung, Tails 2299, Brian Wright, Sisyphos 7771, The Forbidden Juice, RB Racer, Alex Vega, Free D, Michael Cozy, Thalo 215, Crystal Joe, Albert Gun Keekum, Solarize 80, Sprutnik, Brian P, Hoodat 42, Cornster 671, Penta Winter, Hal Richard, Omega Dog, John Wick, Boomstick, Mr. Tiger, State Farm Snake, Hugo, Ander Kiwi, Penguins, Love AI, 3D 37 by 73, Porcelain Oats, Curry King 3, Nixus Mania, Rye Hill Cheap Bulls, Smash Axley, Sheriff Lotfi, Kevin Kuntz, Armand Vacatura, Karam El Masri, Kalen, Ryshell, Jonathan Harris, Kainush Kagani, and Angel of Cake. And of course, thank you to Sahara for the music.